That's it.
Oh, word. I live like right behind.
Oh, yeah.
Yeah. Oh, that's so yeah, we just like.
Will you use the Firefox browser to go on TryHackMe and use VPN?
Yeah, so you do VPN on the Kali.
Almost never.
Yeah,
To go.
We'll go over it right now.
Yeah.
I feel like a huge bitch and like a scene or something.
Oh no, I can go incognito like very. Oh fuck yeah, dude, that works. Go watch this.
No. No. I'm sick of it. Like,
What's it about?
it's like about like some CIA operation or whatever. Basically, it's like being promoted by like a lot of like Republicans and like Trump like
How the hell do I
people
close
like
this?
what's his name?
Then you press
Alex
the arrow.
Jones.
Where?
those
I
kind
can't
of
see.
people. And so
Oh,
we
that
just
thing.
get a lot
Oh,
of
I
crazy
see.
rejects. So
That didn't do
I
anything.
can hate it.
That didn't work.
Wait, what should we do?
Wait,
Huh?
so they're like they're straight up like,
That didn't work.
good.
Oh.
I just said,
Wait,
why didn't you
no,
listen to
wait.
me?
Yes.
Oh, it's right here.
I was gonna go to the library, but then
The bottom.
Miro was like,
Just be like, listen.
I saw Miro.
Oh,
I
you
was
said
gonna go to the library.
Yep.
But he was gonna go up here to like see this year and then just
And
like
they're like almost
someone.
all broken in my computer.
Yeah, it's over.
And that every single guy, like a computer, we're trying to hide their movie.
Wait, so who had trouble getting on to TryHackMe? Who had trouble getting on TryHackMe? Was it like trying to access anything?
I'm just trying
Trying
to
to get onto the home office.
Okay, so there's two ways you can try to get on it. There's the attack box, or there's a VPN. VPN is basically a way for you to get like you have like internal access and you can hit the machine basically. So when you have it on, do you see this on the top right here? Something like that? Yeah,
Yeah, it was at the.
The thing where it says.
isn't it? Yeah,
And it had like a timer.
yeah. So did you guys use any of these?
Yes.
You just open
You did? Okay.
Because attack clock, I think what, it's like an hour and.
Yeah, there's a little-
Yeah.
So
So-
you found out how to connect.
So
it. Yeah, so I downloaded
Yeah,
it.
so if you click on open,
Yeah.
if you click on open VPN and then hit Linux,
The site can be reached.
Oh, okay, then it will show you how to connect.
I will show in a second. And then you see download.
You have to be on the OWASP part to use the VPN.
No, it
I see.
doesn't matter.
Yeah. So you log
I don't remember if I made an account for this ever. So I guess we'll have to.
Yeah, you need to make an account to access it.
I was able to do the assignments without
But.
having to like actually finish one, so.
You should, I think you do.
See if I have it, like.
I actually need to go to the computer store and you need this thing. Take these in.
Yeah.
Here's the witness.
Yeah, 100 होना चाहिए।
I know, he's gonna be fit. That's why I'm telling you. I wasn't telling today. I have to. I'm not doing that anymore.
Yeah.
No.
Focus on learning self-programming. I don't know if I'll hold up on Python, but I'll just get started with C++. Yeah. We can stay storage down. It's like a way for you to. Yeah. So.
Windows, but for now we are working on that. I had seen top 10, some people had published like Huh?
I don't wanna do it.
Oh yeah, sorry. Wait, can you load up the sign?
I think it's because of how much.
The sign-in form? Oh, yeah.
Yeah, this is the past assignment that we have. Yeah.
Oh, yeah. That's what I'm saying. That's why I can do how to. Yeah, that's what you do like to try out some good stuff. Yeah. 0, 19, 38 on there. Oh, fuck, then it's 7 something. It's like 7:47. I don't know what the last 3 days are. Yeah, you literally have to give me credit for. Yeah. 9, 7.
You were wrong.
Yeah. 7. I said 747. It's 9, 7, 4. That's what I wanted.
That's what I thought of. That's actually.
The
Yeah. Wait, okay,
versus second.
Yo, so question, John is just,
It's on.
John is just,
Yeah, so this
collection
one,
of like.
most people have, I think when we. did it
So
already.
John is a way to like crack. Did you learn about hashes at all?
Yeah.
Basically,
That's
what
just-
John does is the way like hashes work is like it basically goes through like a hashing algorithm. So you take like you have like password 1, 2, 3. It goes through this algorithm, basically like warms it up a bit, and then has a hash password. So it's easy. It's harder to basically go like, backwards from it.
Right.
So what John does is basically what it does is it'll get a list of passwords. John isn't the password list. You have it like the password is called like rockq.txt.
Did you guys log in?
I'm still
But,
signing up for.
Basically, it uses that
Right.
list. What it does
But
is you can type in like it'll get the password and then make a hash
No,
of
because I
it,
never made.
and then it'll compare it to. So say, oh, is this hash equal to this hash? No, next word. Is this hash equal to this hash? Next word. It'll just keep going. If the hash is a match, then the password is whatever it is.
I was able to do homework, but I don't think I ever. did
I don't know
it.
what I did, but I tried to calculate the TXT file that they
I
had
can
in
find
John,
my login.
and it kept going. And I was
Yes.
like,
So
I
hashing
tried
is a way
reading-
to
I tried
figure out
reading
one
the-
is not like better than now. So to hash something is really, really
I
hard
have
to
to
work
back
at.
it.
Like mathematically,
Yes.
yes.
possible, but long.
Yeah, but the way that computers do that is like try hashing all the words in the world, try to hash one. If the hash matches,
Right.
the string is gonna be the same as. Have you taken data sciences here?
Let's go to.
You will study collisions in there, so you will study the
So-
hashing method in there and how to, because
Let's
two
go back to
strings
login.
can actually hash to the same thing.
Interesting, okay.
So you have to use higher, like with higher number of bits to prevent that from
So,
happening.
okay, since we're on that, so what the heck is on job? Because I tried to use it and it was like, I understood like parts of it, but I didn't understand all the things.
Fun job. It's basically
There's
like
not a way to
in a
do
really
this.
simple way. It's just like a scheduled task that's done. So basically like
So I saw that. using
think of like
it.
administrators, right? So Linux is usually used for servers. Let's say like you want to go and run updates every week. So cron has a way for basically you can say, I want to run this thing at a certain amount of time. at this set time. So you can say,
So
so
now
every 7
you
days,
understand what a
run this
VPN
thing.
is.
That's what
So you have to
cron
know.
does. So
What is it?
the problem is let's say like you're administrator,
Not
right?
that.
And you have a cron job
Most people
for a
think that it is
file.
that, but what it
And
gives
then
you
you
is
let
that it
anyone
allows
write
you
to
to
it,
access the
and it runs the
computers
hash
which are
function.
inside the other network.
What if you compromise it?
So you
and
see that the
edit their
IP will
file,
have for
do
the
whatever you want
attack
to it.
VM is gonna
1
be
week
something
later,
like
it runs
10.10.
some malicious
But-
code you have, now there's.
Oh, not this,
It's
but
gonna run
like
every 7
the
days.
10.10 when you
Oh,
create the virtual machine.
So,
in there.
so that's what we're doing over here with the shell.net.
Oh,
are we supposed to do that?
Scala.
Yeah.
Because I think I
Start
had to
that
create a
attack.
shell on my end.
So this is the machine that
And
will be
it's-
attacking,
Venom.
but
Yeah.
the problem is
And then
you,
once I create that shell, I had to.
you cannot
transfer it
access the
over
VM
to-
directly, right?
There.
Because it's
Yeah.
in a private
Yeah,
network, so
I
the
think-
VPN
I think
actually
so.
allows
So then
you to be a
I
part
found
of that private network.
HTTP
Does that make sense?
simple, just create some server on
So
there.
when you would download
I was
this, now you want
actually- I actually
to
had a
install
question on that.
OpenVPN
So,
client
I-
to connect to that.
I'll be honest,
So
with you,
download
I
OpenVPN
looked it
client.
up, like I scoured the internet to find like how to do it, but with the server stuff, how do I upload like individual files that I have like up to the server? Because for which code do I use? Because I
And,
concentrated on get on their end.
Uh-huh.
And it wouldn't work. for me.
So this is the software that will allow you to use the OpenVPN file.
Also,
To connect to that,
you posted
hack the- or try hack
on
network.
the actually try hacking, you try
Does
to
that
get
make
it.
sense?
Yeah.
Oh, interesting.
And the update.
It might be a network issue, because that should work.
Okay.
Yeah.
So the only thing is like, because I created a host on like Kali now
Yes.
with them, if I just go.
Do that in, do that in Tally, where you doing that on Windows?
Let's say hypothetically, I just created a file trolling a company. And
So-
then I just like.
Grab the
Go
guy.
to your
Just do that.
VM and then install the OpenVPN in there.
Okay.
Is it running Linux browser?
Don't tell me you forgot the password again.
No,
Yeah.
I was
It's
never
on your-
able to
As long
recover.
as like, is your like terminal?
I've been locked out since like
Did you
Friday
look
night.
to the link that guys?
No, I was trying to prepare for talk to them. When
Yeah,
I'm
you can also try hacking. It's just all.
So what can you do?
Yeah.
So whatever.
I need to do that shit right now.
Yes.
Yeah, yeah, so you get Start Machine and
Look
then,
at the link that guys. saw.
I wouldn't suggest.
I
using
tried to
the,
do it,
uh,
but I couldn't understand it.
attack box, you see
Sorry,
it
because
right now, access machines. So right now it's saying you're disconnected, you have no way to get on. So you have two ways. You can use the attack box, which is going to use the browser, which is super laggy, or you can use OpenVPN, which is basically, you can access it from anywhere on your computer. So if you hit that and then hit down.
Oh, yeah, please, I can't figure out how to open. Sir, I don't know how to get into this menu.
So you see initially when you would start the computer, it gives you a black screen where it says Kali, Linux, GNU and advanced options.
Yes.
Try to be, but one thing, let's look at the next step. Go to the thing,
You run OpenVPN, so it's like.
scroll down, what does it ask you to do? It asks you
That's
to
all my
press the
thinking
command,
initially.
press the button
Oh,
E, I
yeah.
think that's what it is.
You take that concert or whatever.
So yes, go ahead, restart your machine and then it asks you about the Kali GNU/Linux.
But this weekend, my last.
With Windows, in Linux, you see that with Windows, you have to download stuff from online. With Linux, you don't have that. You open the terminal, go to the Opera,
Yeah,
Yeah, so
I
you
got a
just browse
scholarship
it.
with them.
and you see sudo apt install OpenVPN.
What percentage of the car is-
So use that command and it will install OpenVPN in your local laptop. In Linux, you don't actually install stuff from outside.
What? Not like everything.
So now,
It actually, the Kali, the people who created Kali maintain a list of software, so they allow you to just write the single command and install it. It's installed.
it's basically you're trying to.
So now download, open your TriHack key in here and download the OpenVPN file. Yeah.
Yeah, I.
Yeah.
Yeah, so now you are, and now you see what
So
is.
you always.
Or do we have to like download?
No.
He was not- he was-
You just.
So now, go to your, go to the and see it says you press E and then you are on this line. So now it's saying scroll down until you get the line started with the key.
Yeah, oh, yeah, there is more, but a lot of them are like, like 5 yeah.
It says something of me.
Yeah, cause you
Yeah.
did the bullshit stuff
So
like.
now,
like,
go back to the-
You did like.
Well,
after the picture,
Oh, okay.
now you have to look for the.
To me, I
Why
was
is it?
like,
Okay.
for the first, like, I think the first
So,
2 weeks. I was
go
on,
to the right.
Yeah.
No, bro.
Yeah. No, R would be separate.
we lost that much right
Oh,
now.
there it is.
Read only. So yeah.
So it would be a read,
Oh,
extra.
Yeah.
Now go back to this.
Read right now, right? And then.
Replace it with init equals with slash. So why?
Wait,
I-
wait, so what was your CF strategy?
SU?
Yeah, that space.
Init equals bin bash.
I've done all the CS classes.
Oh,
Like, I
all
Equals
And then
Slash
the-
bin?
and then the-
No, I took down.
bin slash bash.
I
Go back
love
to the thing again.
No, no, no. If you're fine, like,
Right,
DJ.
Go to the thing.
No,
Let's
I
scroll
had
down.
someone else, the friend.
Scroll down. Check RW permissions on the root
But
outside.
then-
Now.
Oh,
Okay,
yeah.
now
Oh,
we
yeah.
save it and then restart it.
He complained about
And
it.
in order to save it,
So we're out.
So you're like, eh.
Oh.
I did my intro with this, so.
No,
I know my password. He goes in a lot of depth about like the basics, so.
You should.
I also like, he tries to set you up very well for data structures, I feel like. Yeah, but.
Because I feel like data structures and like.
Why? Yes, control X
Like-
to.
She did
So
Luciano.
now it is
for-
actually used to
Intro.
learn about the Linux boot process.
Wait,
which
so
you'll
yeah,
study
here,
it.
data structures going.
But it we just changed
How was
it
it?
to a point where you don't have to log in to get the
It
shell.
was fine, but like,
So you see that you would get the.
Like,
It will actually allow you to get the shell without even logging in.
so it was mostly on
What do you
binary
mean?
search trees.
Like when I do
binary
SSH or
trees,
how?
You'll see it in a second.
only basically everything else.
Yeah, okay.
A lot of forms and like usually.
Did you have to do like a big project? Oh, that makes sense. It's gotta be a project to do with I.
Wait,
how-
Don't take.
I think.
Oh, wait, I wanted.
Oh, that's not what
Yeah,
I
no,
Yeah.
Luciano has no words, but
Oh,
I feel like he builds it
So,
from
this is what, if you need to.
So wait,
Yeah.
So wait, I'm taking.
The whole thing?
Okay. I have kind of landed on the group of like either take Luciano or Wait, how's your phone? No, okay, the thing is, he
No, but
makes
his
shit
phone-
like very difficult. That's the thing. For
But
like,
you actually know what you're doing afterwards.
yeah.
Okay, would it be good to discuss something?
Fuck no.
I wouldn't.
Dude, I don't have a choice. It's like, I don't have anything. If you're gonna take Luciano, you better take him in person, cause.
I
if-
can't.
Dude,
Like,
you're gonna get
I
lost.
genuinely cannot.
Take it
It's
as a-
impossible.
Switch
my
something
schedule.
around.
No, I can't switch. I have.
Take physics at another time then.
Do that, yeah,
I-
take physics another time.
No, because I'm.
Peter Whitman has 2 classes.
I know, I'm taking it the other one. I can't get into your classes.
Right. Oh, it ran out of
Yes,
the spot.
he closed it. So. There was still one seat left.
Why don't you change your password? How is it complicated?
No, you can't change your password.
Restart the thing. Restart the thing.
It's hard though.
No, it's not like, it's not hard. It's like just change password.
Your password, I understand your password is very hard. But. So
Yeah,
I can see here, so.
Okay, enter.
Yeah, so it's like.
I use Mac.
I use Mac.
I typed what? I use Mac.
Okay, okay.
Now.
You know what?
Smart phone,
Right there.
cloud
Right
service.
there.
You don't see his
And
password?
copy and paste it. I'll do it. It's okay. I won't.
That's really cool.
Man, you're wrong. Dirty cow, it's called dirty cow, damn it.
Restart it, go to the web again.
And I finished my.
Yeah, I click on there.
I goes down.
Okay, now I'm
Go to the game like.
Right.
I'm always on the go to the gym.
With-
Yeah, you press the right button.
Oh, right.
So RW
That's good.
and white will be.
It would be init equals slash,
Yeah, we can work out that we get.
Go to the no, the slash.
Oh, yeah.
Go to your.
And then I hit command.
One second.
Bro, okay, bro, I'll tell you what.
I'm not doing
Should I get a read the right?
Put me in it.
Now.
Oh, you need to press
Wait, where's the signal? Where do you get that? Oh, because that's what you do. Right,
The
right.
reason we have to do this is.
That's your,
The honors is.
Here, it's like. you want something.
Oh, yeah, that's true, because that's the text up there.
It's not on the internet.
Oh. You're thinking.
How do you?
Let me tell you, this called. I call it called the receipt.
You're connected to the internet that I just like, you see it works. Go to the internet.
It's called an Nasir. Yeah.
No, no, for example, it connects to their network.
Oh, it's
So it's like you connect to their network.
He's like an advanced
I know.
You're like remotely connected.
To a different network.
Yeah. you're
And then
not
they can't
going
deny
to
it, so
but you're also-
have to like.
The slides in Discord, you need to like.
yeah, identify. So it's connected to this service and also connected to another. And therefore, he has to be.
So that's how you're.
Right, so the example you otherwise.
No, this is not hosted here. It's not hosted on the internet. So it's hosted on their network, which you're connected to, which is why you can hit.
Yes.
But if you disconnect the VPN, you can hit this.
Now I understand.
Do it less.
You should have it.
You should your opinion, really.
Yeah.
LS.
Bro,
So- Yeah. I'm
Some
gonna
really
try.
complicated things. I'll never guess it.
Like yesterday.
After round three?
No, like. broadcast,
Oh.
It's not.
dot,
Why did you change your password?
You gotta connect, right?
question mark.
Yeah, but I looked myself up. So
My terminal go.
just with.
Okay.
What's the last one?
LS.
So I did both the track actions. What was the last one?
And CD.
No, that's,
Web apps, right?
yeah.
Have you ever used a honey?
That's cool.
No, I don't know.
Good idea. I thought it was like.
Okay.
So I'm like, how hard is that? I don't know why. I love it.
Yeah, I had 81 slides.
Yeah, so this one's gonna be a lot.
Where's my, where'd it go?
LCR calculator.
I'll see your telephone.
I'll see on the phone.
Nice.
You know, I just want to take the exam just to show them like that's
Okay.
That's what you.
Oh, they give you like admissions exam. You see or
Yeah,
Oh,
yeah,
no,
yeah.
no.
All right, we're gonna start right now. So yeah,
Are you recording?
I think so.
Lucy, is it recording? Is it recording? Okay.
Cool. All right. I'll try to take my time, but there's 81 slides. So yeah.
81.
Yes, there's 81 slides. Because I love Windows. Anyways, yeah, so this is intro to Windows. But before we start about Windows, I want to talk about shells because we talked about that kind of a little bit last week. But basically, shells is like your way of getting initial access, right? So when someone says, oh, I got a shell, something like that, that's basically saying you got initial access. So shell basically means you have some sort of way to get onto a terminal. So when you open up your terminal, run ls cd, that's basically a shell. And so how do you even get initial access? So last week we talked about how web apps, your main way of like trying to get in is you're trying to execute code to do some stuff. So we mentioned a lot of times like, oh, you can read a file, you can do that. But how do I just get full on access to a server, right? So you need a shell, or basically you need RCE, which means remote code execution. And if you kind of think about that, if you're remote, you're like far away, code execution, you can run code on something. So you can remotely execute code on a server from your house or wherever you are. So how do you do that? Basically, for getting a shell or running, or like basically getting a shell, the concept of it is you're trying to establish a network connection from a compromised host back to yourself. That makes sense, right? So if you're trying to get onto a server, you need some way for it to connect back to you so you can do whatever you want to it. So that's the whole concept of getting a shell. And what you want to do is to get this connection, you need to basically be on your attacker machine, so your Kali. You're going to have to listen to it. So you're basically listening for a connection. And the way you do that is you open up a port on your Kali Linux. And this port is going to be waiting for any connection to come back to it, right? So from here, what you do is you open up a connection, and then you have the compromised machine call to that port and connect back to you. And then what that kind of looks like is like this. So on the left-hand side, that's like your Kali Linux, so your attack box. Basically, what you're gonna be running is that nc-lvp, and I'll go over what exactly that means. And on the target, basically the target you're trying to compromise, it's gonna be running that command. So when I say, oh, you can attack a web application and make it run commands, you'd be wanting it to run something like that, the nc IP address, port number, and then that bin sh thing. Basically what that's gonna do is establish a connection to your Kali Linux and give you terminal access to it. And on the next slide, you'll kind of see what that does. So the flags, basically for the first one, so your Kali Linux, it has LVMP. So it's listening mode. So it's basically listening for connections. It has a verbose, so you have more output when a connection comes in. -N basically says you only want IP addresses, so you don't want domain names like google.com, youtube.com. And then -P is the port that you want. So the port that your Kali Linux is going to have listening to it. So it's basically going to listen, it's going to wait for any connections to its IP address on that port. So port 4444. And then on the target machine, so the compromised host you're trying to get onto, it's running NC, an IP address 4444-E bin sh. Basically what it is, it's running netcat again. And the 192.168.1.1 is your Kali Linux machine. So you're basically saying to the compromised host that you want it to connect to yourself on port 4444, because that's also the port that's basically waiting for connections on. And then the -E bin sh, basically what it's saying is it wants to execute something. And you're telling to execute bin sh, probably wondering what the hell is bin sh? It's basically a way for you to get terminal access. So when you're doing all of your terminal stuff, it's running on a shell, and that shell is called bin sh. So you're basically saying, give me terminal access and run bin sh. So call to that port, call to my IP address, and execute a shell so I can get access to it. Does that make sense to everyone? Any questions?
So
Yeah.
BinSH, so this is us telling the target to connect to, like, so BinSH is the thing for like Linux. So
Yeah, it's like
that's not what I would use, let's say, if I was trying to get into something from like the Windows.
Exactly, yeah.
Okay.
Yeah. So for Windows, it'd be cmd.exe or PowerShell.exe. Those are the two
Those
that
are
you
type
use.
of shells.
Yeah, so those are all shells. Like when you see like cmd or PowerShell, those are types of shells. On Linux, there's bin sh, there's bin bash. Those are all basically, you can think of it as just a terminal. So when you think of like shell, just think a terminal, so you can run commands on it.
So, but isn't Netcat like Linux only thing? So
Exactly, and I will get into that because yeah, that's a good point. Yeah.
So is the shell thing? What's like Windows PowerShell? Is that, how is that related to this?
Yeah, so you know how like when you're on Kali and you open up a terminal, you can like run ls, cd,
Yeah.
stuff like that. So PowerShell is the same thing, but on Windows.
So it's
But
like Windows version of the Kali terminal?
Yeah, basically.
so terminals run on top of shells, and different shells have their different shells have their own like kind of like language. So like ls won't always work on Windows because Windows has two main different shells, which is CMD and PowerShell. So I'm pretty sure ls doesn't, or okay, for example,
Yeah,
Yeah.
I can actually show you right now. I actually have a Windows machine. I
so
can-
ls won't work on like every single shell. It's like it's mainly with Linux based shells.
Yeah, so I actually have a Windows machine right here. So I can, so there's basically two. So there's I can't see it, but there's, so there's this command prompt, and then there's also
So command prompt is running on CMD.
PowerShell. So these are two different types of shells. So they kind of look the same, but they're not. So for this one, if I can zoom in, hopefully, nope. Okay. Oh, I turn on magnifier. I guess this will work. So if I run ls on PowerShell, it actually knows how to interpret that. But if I run it on, oh gosh. Okay, if I run it on here and type ls, it's gonna say, oh, okay, it works because I have some weird thing on it, but usually it'll say it doesn't work. So what you'd have to do is run dir, which is like directory, and it'll show that instead. So even though like it does the same concepts, like the syntax is weird, like it's different because like it uses different binaries.
So if you guys run like ls on your Windows host right now, like you open up command prompt, it won't work because it's expecting dir, and his works because he has like some configurations that allow that. But if you run it on your Windows host machine, you open up command prompt and you try to run ls, it won't interpret that properly.
Yeah, that makes sense.
Yes.
Yeah. Okay. What's up?
What does NC?
That means netcat. It's basically a way to connect to an IP address and a port number.
Yeah, it's a binary. It's a
Yeah.
string that you can use.
So it's not like a command.
It is a command.
It is command. It's a binary.
Yeah.
Just like ls is a binary, nc is a binary.
Makes sense? Yeah.
How do you get which port to connect with? You just scan and see which port's open.
No, so for this one, basically we're assuming that you have some sort of way to run commands on a server. And basically what you're saying is that port number, that 4444, is your own port that's open. And basically what you're saying is that port that's open, you're telling the compromised server to connect back to you. So now you have access to it because you can connect, because it's connecting directly to you.
Do you know which port is open on your laptop?
You can pick whatever one you want.
Open it.
Yeah, you
up
open it yourself.
Or should you just like
Yeah.
a command for it? Or
Yeah, it's the top one. That L is basically saying, I'm listening, I'm waiting for a connection. So you're opening a port up with that. And then you're telling it what port you want it on, 4444. Yeah, so it can be whatever you want.
is there some ports that I should not, port numbers I should not use? Or
There is. So basically like what you'd want, well, there is, but there isn't. So basically it depends on how quote unquote noisy you want to be. So if you want to like stay like under the radar, you'd have to look for ports that are like most used. So if I was like an attacker attacking a company, you'd have to think what type of ports, if someone was like monitoring all of the network traffic, what ports would you see a ton of? Web traffic, right? Like people are browsing on the web. So that's 80 and 443. So if you're trying to get a connection back to yourself and make it look a little bit more hidden, you wouldn't want to use like 9,000 or something like that. That's way too high. So you'd be like 80 or 443, you can connect back to yourself on that. Yeah.
Also, you're probably wondering like how do we even like execute the bottom half, like the NC 192.168 blah, 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 and then execute bin -sh. So what we call that is like a payload. And so like Bryce said, we're assuming that we have some kind of access to the machine where we can run commands. And so we can, or either we have like file upload and we can execute the file. And so we can maybe either stick that command into a file and hit the file and make it execute, or we have direct remote code execution where we can execute this command directly, which establishes a connection to ourselves. Does that make sense? That's how we would use this command.
Yeah, and I can actually show you really quickly too. Where's my mouse? Okay. So I have two VMs open right now. So there's a Kali and there's Windows on the side. So let's say that this Kali machine is our compromised server, right? So basically, and then on this side, it's like our attacker machine. So and it's really tiny. Oh, there we go. Okay. So you mentioned on the slides before that the attack box is waiting for a connection, and then the target is what is establishing a connection back to ourselves. So we can basically mimic this. So we can do nc-lvp on these ones. So this is the right hand's going to be in my attacker machine. So we do nc-lvp 444. It'll say listening on 0.0.0.0, which basically means that any IP can hit our machine, which is exactly what we want. And it's waiting for any connection on port 4444. And then let's assume that on the left-hand side, this is our compromised server. So we can run commands on this, either through a web app, we have like some sort of way to run code on it. Basically what we can do is we're gonna do netcat, and then the IP address of this one, which I have no idea what it is I can't see. Oh, 10.100.10.34. So on the left hand side, we're going to say 10.100.10.34. That's the connection for our attack box. So that's like our own machine that we're trying to connect back to. And then we do the port number, which is 4444. And then we want to execute something, which is bin sh. So that's basically saying we want a shell from it. If we want to run that, you see it says connection from 10.100.10.35. That's this machine right here. So now if I go here and do like ls, this isn't my machine running it. I'm running commands from here now instead. Like if I run like, who am I? I'm Kali. This is Windows on the right, not Kali. So this is me running commands on the left-hand side from my own machine. So now I can run whatever I want, go wherever I want, and do stuff like that. Does that make sense? Yeah.
Okay, me first. The IP that you used on there, let's say you were on a VPN, which is because the IP that you're using there, that's your machine IP, right?
Yeah.
So if I use a VPN, then that's just network being like hidden. So I would still use the machine IP, or would I do whatever is?
So are you trying to connect back to yourself, or?
Yeah. So I want to connect their shell to mine.
Yeah, so when you're on a VPN, it'll assign you a new IP address on there too. And it'll be like when you run, let me see. You see how there's like these ETH1, LO, ETH2, whatever. When you're on a VPN, it'll usually be under like ton0. That's basically a network interface for a VPN that says this IP address is a VPN IP address. So when you attack a machine on a VPN and you want to connect back to you, you basically say, I want to connect to this VPN IP address because you're both on the VPN.
Okay.
Yeah. Any other questions?
So if you connected to this is another laptop. If you connected to this laptop and like the guy controlling this laptop, and can he connect back to you and mess with your stuff?
No, he can't. But they can see that you're connected though. So what if I do this, and then I can't see if I can make any tab. Let's see. We can I see that? Oh, that's weird. But yeah, you should be able to see there's like connections from that machine that's constantly going. So that'd be weird.
Okay, but they can't access you back.
No. Yeah. Your question?
So the one on the right is the one executing the commands, or?
That's the one listening. So that basically assume the right one is like the one like your own machine that you have access to, and the left one is the compromised server. Yeah.
Can you run a command from this one to this one? Just to see.
Oh, what do you mean?
So
Okay, so you can run commands from this one on this one.
Yeah. So like watch it. Let's see. So if I do like, notice all of these files, right? There's like this like cups, root file, read, chisel, whatever, right? And if I do ls here, they're not the same at all, right? They're way different. So if I do that connection again, let me clear this. So I run this. So I'm waiting for a connection. I establish it. And if I run that again, you see there's like that cups root file read. So now I am basically running commands on here from my own computer. That makes sense? Yes. Yeah.
And then how do you get, so you need that initial access in order to establish the connection?
Yep. Yeah. So you need some way to run commands. So that's why we're like harping on so much last week that
Right.
you want a way to like run commands. Because if you can do that, you can maybe do that to like the web app somehow and have it connect back to you.
So the important thing is getting that foothold in order to establish a connection.
Exactly.
Once you have the
Yep.
connection established, you have kind of free reign from there.
Exactly. Yep.
Because this gives you more power, right? And you have more
Right.
access and things like that.
Yeah. Because basically it's like another computer now that you have access to. Yeah. So I want to go over that really quickly because we didn't go over it last time. And then we brought up the whole thing. Well, what if we don't have NC, right? What if we don't have Netcat? What if it's Windows? Because Windows doesn't have Netcat by default. There's a great site called RevShells, and I guarantee you it's probably blocked, and it's not. Cool. Basically, RevShells is a website where it'll basically automatically generate these like payloads that so he was talking about. And a really simplified idea of like the thing about it is you don't have to understand what this even means. The only thing you need to understand is that all of these commands are doing one thing. They're establishing a network connection back to you. That's all they're doing. So if you can run any of these commands somewhere, all they're doing is trying to they're looking for a port. You see it right here, this port, and an IP address. And you can actually change that right here. So if you know your IP address and the port you're listening on, you can change it to whatever you want, copy these commands and try to run it on a server, Windows, whatever. And when I say Windows, you see there's actually things you can use. So there's Windows, actually you can sort by Windows, I think, yeah. So all of these might work on Windows. And then there's PowerShell, which we mentioned is the shell that we use for Windows. So you can see it's like a little bit different, but if you can run these somehow on a Windows machine, and then you have your host, whatever, to listen on, then it'll go and give you a connection back. That makes sense?
What's this website called?
Revshells.com. It's right here. Yeah, and I listed some of my favorite ones to use. This NC MKFIFO literally it always works on Linux all the time for me. I don't know why, but it's like my favorite. There's also one like this PHP one. So if you can upload files somehow and you can navigate to it, you can actually go and make it run. I can maybe show that after if I have time, but yeah, so these are like my favorite ones to use out of the list on there. So yeah, if you don't have Netcat like it does on here, go on revshells.com, try to just paste those in, and if one doesn't work, just try another one and try to get a connection back. So the only thing that's changing is when you run, the thing that's always been constant is when you're on your attacker like machine, you're always going to run this somehow, nc-lvp and a port number. It can be whatever you want. And then the thing that'll change is that RevShells thing. So we can actually go and like do an example really fast. So if I go to RevShells and go here. So we know my attacker machine, the port was 10.100.10.34 and the port is 4444. And then if we go to like this one that I mentioned, you can literally just hit copy and then go back and hit paste. I have no idea what the hell that even does, honestly, but if I hit enter, boom, connection. I have no idea what it did, but all I know is that the point of it is to establish a connection to my machine. Does that make sense? Cool. All right. So that's if you have to like run commands to like a website, something like that. But what if like we mentioned vulnerable versions of things, right? So if something's really old, you can maybe get like a shell on it somehow. Well, that's where Metasploit comes in. So last week we talked about ExploitDB and Searchsploit, and as a recap, basically what this is it's a database of known exploits. So if we go, oops. Whatever. I can do my VM because it doesn't matter. Let's see. Loads. Exploit. So you see all of these things right here. It's basically a bunch of services that have known exploits to them. So you can like click this one and it says, authenticated remote code execution. We talked about RC before. That basically means you can remotely run code somewhere. Authenticated, which means you have to be logged in somehow. So for this Icinga, whatever, Web 2.10, if someone was hosting this online and you found it and you can log in, you can get remote code execution just by running this code that you have no idea about. You change some things about it, run it, and you might have access to something. It's as easy as that. So yeah, so basically that's what Metasploit is. It's basically, Metasploit is built on top of that. So it's a framework, and basically you have the ability to like do like scanning. So you can search for vulnerabilities. You can do exploitation, which is the big one. You can do like exploit development, post exploitation, which we'll talk about later. But the main thing is that it has these modules in it, which is basically like a plug and play sort of functionality. So if you find a known exploit and Metasploit has a module for it, it can be as simple as just changing an IP address and a port and hitting execute and just run something. And here's like a little example. So basically there's a module called MS17O10 Eternal Blue, which is like a really old exploit for Windows, and it'll probably be part of your homework. Basically all you had to do to run this is you had to change the IP address and the port and just type run, and you can see they get a shell like that, probably 10 seconds of work and it's done. So that's kind of what it looks like. Anyone have any questions about Metasploit? It's just a really easy way to go and get shells because it has exploits already built in, change some things, hit run.
So how to download it?
It's on Kali already. So the reason why I'm like harping about using Kali so much is it has all the tools you need already there.
So it's just kind of like an external database of known exploits.
Yeah, exactly. Yeah, so basically it has a bunch of like known exploits, and they have modules, and these modules basically just code that people built already. You just change some things about it, run it, boom, you gain access.
What website would you go to for Metasploit?
Oh, it's actually if you want to use it on your terminal, you type in MSF console on your terminal, and that'll open up Metasploit. Yeah, I probably should mention that on the slides. Huh? I'll show you that. Oh, it's right here. So if you go on your terminal, close, whatever. Just type this MSF console, just like that. Hit enter. It'll take like 20 seconds to load sometimes. So yeah, you'd see something like this. Basically, if you want to like search for an exploit, you just type search and then whatever you want. So they mentioned Eternal Blue last time. So if we type search Eternal Blue, it'll show you all the modules they have for it. And you can pick which ones you want and then just run them essentially.
So this searches for exploits in a website?
Yeah, so Exploit DB is basically what has all of the exploits already on there. And then Metasploit will have modules for that where you can just change some things around and run them.
But you need to like list the website first before it knows what to search for?
No.
No, it's already linked. Like it knows like what database it's searching to, which is ExploitDB.
Yeah, so basically Metasploit already has built in to search for exploits from that website. So it's like a built-in functionality already. So it'll search through that website on its own.
You just gave me a picture of a rabbit.
Oh yeah, yeah, it has like little like ASCII art sometimes. Yeah. But yeah.
How do you run the exploits?
How do you run them?
Yeah.
That'll be part of your homework to figure out. Yes. It's easy, trust me. It's super easy. Also, there'll be a lot of exploits like that on the triads. It'll be easy, trust me. But yeah. Oh, good question. I'll post on Discord later. There's a way to do it. It's super easy. It's like one command. I just can't remember what it is off the top of my head. Any other questions? All right. Cool. So let's get into Windows. And the first thing is about Active Directory. So basically, when most of us think about Windows, we think like our laptops, right? But in like corporate environments, it's Active Directory, and it's a really huge thing. And the reason why I love Windows so much is if you compromise Active Directory, you compromise absolutely everything. So yeah, and I'll get into how that is. But what are you laughing?
I love Windows so much.
Yeah, but yeah, anyways, Active Directory, also known as AD for short. Basically, what it does is it runs on domain controller, and domain controller, all it is a server that can go and consolidate data and safeguard network security. And basically, the main way it does this is by making sure you are who you say you are, and basically authorizing users. And it's installed by default when you run this ADDS thing, Active Directory Domain Services. You don't really need to know that. But basically, the main thing you need to know about Active Directory is that it contains the ability to basically like administer computers, groups, accounts, printers, file shares, basically anything like that. So like if you go to like the library and you can connect to like your Fullerton College email and like it has all of your stuff about it, it's because each and every single one of you is like a user in their little Active Directory database, and they can manage who you are, what you have access to. That's why your teachers can have certain access, you can have certain access, and they can basically delegate out exactly what you want. So you can basically assume that if you're a hacker and you can compromise this whole entire thing, now you have access to exactly what you can control. You can give yourself full access. You can remove absolutely everything. You can remove everyone. It's extremely dangerous. So if you can get full access to this, you can basically go and say, hey, this company, you're screwed forever. Give me money, whatever, if you were to ransom them or something like that. Yeah. So yeah, so why would people even use AD? So why would people who are in security, who have a company, why would they want to use AD? So basically the reason why you want to use AD is it's super useful in terms of administrative tasks. So I mentioned there's like basically a central way to manage your resources. So if you have computers, users, printers, whatever, there's just one thing you can use to go and manage all of it. It's also good for security too, because I mentioned before that the domain controller, the main point of it is to authenticate and basically delegate out tasks. There's integration with things. So there's like Exchange, SharePoint, Exchange being like your email, SharePoint, like file sharing, stuff like that. You can scale a lot. So just like I mentioned, like at a college, you can just add another user, boom, done. You don't need to do anything crazy. There's an automated task to do that. Super easy, and it can scale really, really well. And then group policy management. Basically what that is that you can allow administrators to go and apply policies to a group of people so that it can be like security settings, configuration settings, whatever. You can basically run policies, do things like that really easily compared to having it doing it one by one, which would be like an absolute hell for like an IT administrator. Any questions like that? Basically, AD is the go-to thing for people who are in IT to go administer their company, users, stuff like that. Okay. So basically AD has a little infrastructure to, or a structure to it. Basically the three main things to it is there's a forest, a domain, and then organizational units. So when I mentioned domain, you might be thinking like domain names, right? Like google.com, facebook.com, Twitter, whatever. It's basically like the same thing as that. And basically a forest is a collection of domains. And so each domain basically can have its own little purpose. So you can have like, let's say like student.fullertoncollege.edu, and then you can have like it.fullertoncollege.edu, and you can kind of separate out what you want people to do. Or you can even have it be like development or engineers or stuff like that. You can have basically its own domains to go and basically logically group out people. And then the forest is just basically a compilation of it. And I'll show you on the next slide what exactly that looks like. And then the other thing is a organizational unit, which is a container object. It's basically used to organize resources and delegate out administrative control over it. And now basically what this is, that's what the AD structure looks like. So the blue triangles is the domain. So I mentioned how like facebook.com, twitter.com, whatever, same thing. So this is like the acme.com. This is like the highest level domain. And then you can see they have subdomains. So there's sales, there's PR, this whatever that says TRE, has accounts in engineering. So all of these together is called a forest. So basically the collection of all domains is the forest. And then within it, you have your little organizational units. So you can have like IT, you can have HR, you can have whatever you want. You can basically organize them in a way in each domain. That makes sense? Cool. Okay. So there's also security groups. So basically security groups is exactly how it sounds. You can basically group people up, and it can consist of not only people, but also like computers, your printers, file shares, stuff like that. You can group them all up into groups. You're probably wondering what's the difference between OUs and groups, because like I mentioned before that you can group up people into an organizational unit. We can also group them up in terms of groups. The main thing that you need to worry about is OUs are able to delegate control, and then groups basically are permissions and access controls from it. So you can put like group policies to these and permissions to groups. So yeah, basically OUs is for like administrative purposes and groups are just for security purposes. That makes sense? Cool. Okay, so now let's talk about Windows Registry, which you guys might have used, might never have used. Does anyone know what registry is so far? Windows Registry, have you heard of it before? Okay, well, I used to hear it when I was a kid a lot because if you were to like pirate things, something like that, they'd be like, oh, change the Windows Registry and do things. And you'll see why it's really terrible in a bit. Basically, the Windows Registry it's basically a database that's used for your operating system to go and have a configuration for hardware, software, stuff like that. So when you have like a new program that you install, or like a new driver, you're installing things, it basically installs it in this database called the Windows Registry, and it contains information about the hardware, software, whatever you downloaded on there. It doesn't always do that, but it's just a great place to stick it if you're a developer. And it also has some sort of hierarchical structure, which is it has hives, keys, subkeys, and values. And we'll go over exactly what all of those are. And I have some use cases that you might see it. So if you're like storing, like if you change your wallpaper or if you like change your icons, stuff like that, the Windows Registry will go and save all of that. If you have like hardware, so like your graphics card, your CPUs, like whatever like that, all of the configurations will be saved there. And then also just like general like security settings, networking, optimization will all be saved in the Windows Registry. Okay, so I mentioned that there's basically a structure. There's hives, keys, subkeys, and values. So basically the hive is the highest part of the structure. And it's basically called, it's like the root of the registry. And basically it contains 5 different things. So like this root, there's HKey classes root, HKey current user, local machine users, and current config. The 2 main things you need to worry about are like these ones. The HKey current user is basically, imagine you're on a computer and you have like 5 different people who let you use your computer. Basically what this one does is it delegates it out to whatever account you're on. So if you change your wallpaper on one account, but like your mom has another account and has a different wallpaper, the HKey current user basically delegates out which configurations are on. The local machine is the whole machine in general. So if you change something in here, the whole machine will change regardless of who's on the account. That makes sense? Those are like the 2 things you really need to worry about. Okay, so then within all these hives, there's keys. Basically, key is like a container object. And basically what that means is like you can store data within it. So that's where like basically, if you were to like install a driver for like your graphics card, something like that, there'd be a key for it called like NVIDIA or AMD or whatever graphics card you have. And it basically will have all of these subkeys and values, which we'll get into. It's basically a way to like just organize how it is essentially. So within the key, there's subkeys. So let's say like you have NVIDIA, right? And let's say like there's like the driver, there's like optimization. So they're gonna have subkeys within it. So it's gonna be NVIDIA and then like graphics and then like optimization or whatever. And basically what it does is it's a way to organize it. And then finally within the subkeys is the actual value. So you wanna like actually run something. So the values is actually like the actual data that you're trying to go and configure. So if you told like your software, oh, I want it to run on boot, I want it to go and do these certain things, that's where all the values are. So within the hive, there's these keys. These keys are subkeys, and then subkeys have these values to it. Now I can actually go and show you what that looks like because it's probably hard to conceptualize. Let me show you here. So if we go to, gosh, this is annoying. Reg edit like this, it'll say your registry editor. And then this is what it looks like. So there's a shit ton of stuff. Basically, you can see the hives, right? So we just mentioned that. So this is the top of the hierarchy. So if you go to current user, you can see there's a bunch of things like control panel, there's printers, network. So if we go like the printers, this is the key. So there's a key called printers, and now there's more categorization under that. There's like this DE, dev module, dev mode, whatever. And then within that, they have, so this is the hive, the key called printers. a subkey within it called like dev module. And then within that, they have its values. So this is like the values of like what it wants it to go and they configure whatever. So there's obviously nothing in here, but there will be like other things. The big one is like the HKey local machine I mentioned, because it has like a ton of like basically like Microsoft, all of your applications will basically be on there. So that's why I think these two are the most important. Basically, it's just a way to store configuration settings and stuff like that. Any questions on that? Cool. Okay. So now a lot of us just basically go and use computers and don't think about how exactly everything works, right? We log into something and say, oh, we logged in, right? For Windows and hacking it, it's actually pretty important to understand how it works because it'll better help you understand like attack vectors and stuff like that. So basically, when you go and like log into Windows, you might be wondering now, like, how exactly does it know when I type in my username and password? How does it know that it's me, right? We mentioned last week that when we're doing like web applications, that they use like databases, right? They have like MySQL, they have like MariaDB, basically some sort of database that has it, right? So Windows also has it, but it doesn't have like a database like MySQL and stuff like that. It actually has something called basically SAM, NTDS, and LSAS. And I'll get into that in a second. So basically SAM, which stands for Security Account Manager, it's a database used at Windows to basically store your user information. The big ones being your username and your password. So when you go and authenticate to your computer, you type in your username, type in your password, it's going to go to the SAM database and identify your username, password, log you in if you are who you say you are. And it's actually stored somewhere on your computer. So if you were to go here on your computer, system root, system32, config, and everyone always says, don't touch system32. That's because there's configurations like that are there. So if you delete all system32, you'd also delete the ability to authenticate. So that would suck because you can never log in again. So that's why they have like barriers to go and not let you do that. But the main reason why it's important to access it is that if you're a hacker, maybe you can access it and then actually read the username and passwords, which we will get into later. So this is for SAM. So this is basically your own computer. It's like your own local machine. This is what will go and store your authentication. But we mentioned Active Directory, right? It's basically a Windows server used to go and authenticate for a corporation, right? So people are going to authenticate to the domain controller, Active Directory, not their own machine. So what about all of the accounts that this Active Directory, this Windows server holds? What if, do they use SAM? No, they use this ntds.dit. Basically, it's the same exact thing where it's just a database, but it's used for a Windows server. So rather than only having your own computer's credentials, it has every single credential for the whole server. So if somehow you're able to compromise Fullerton College's Windows server and got this file, you would have every single username and password to every single person that's on it. So tens of thousands of things, right? Not to give you any ideas, but yeah, just showing like the severity of it. Basically same thing, just way more detrimental. And you can also access it, it's a file too, so yeah. Okay, there's one more thing called LSAS. So LSAS is basically, it's not a database, it's a process basically. So processes run on your computer, and what it does is it's responsible for authentication as well. But the thing that's interesting about it is that you can actually get the process and basically find the contents of it and find passwords and usernames in that as well. So like when you authenticate the things too, it not only uses SAM, but it will also use LSAS sometimes as well. So there's like basically 3 ways to authenticate, and they're all good attack vectors to go and try to get credentials from it. Okay, this one is actually probably the most interesting and actually the most prevalent in real life. It's called DP API, the data protection API, or I call it DPOPI because it sounds funny. Basically, Windows has a way to go and it basically has like a data encryption and decryption service. That's like the formal definition they have. Basically what it is that when you go and like sign into like Facebook, Twitter, Google, whatever, and you log in for the first time, it says, would you like to save your credentials? And you hit save. That's your operating system saving your credentials, and it encrypts it and sticks it on a file on your computer and saves it there. Because it needs some way to access it again, right? How's it going to access it like out of thin air? No, it has to access it through a file. The thing is that if you were to compromise someone's computer, you can actually go and decrypt the file and access their credentials that they've been saving on their computer. And this is a really, really prevalent one because if you're attacking a company, the three things that they're going to monitor the most are these: SAM, NTDS, and LSAS. These things are probably extremely protected, but if you were to go and gain access to their browser credentials, let's imagine like you guys have all heard of GitHub, right? It's basically like a code repository. If you were to hack into an engineer and they're like a senior engineer and you got their credentials at GitHub, that's huge because now you can basically access anything. You can access their GitHub repositories, you can change code, do commits. That's extremely huge because now you can just go and basically act like them and do whatever you want. So that is extremely prevalent because like people will just save their passwords like crazy because they're like, oh, I don't want to type it. It's too much of a hassle. You can just grab everything, and then password reuse is big. What if they use like password 123 exclamation mark on one thing and they didn't save it for some reason on like Twitter or something like that, right? You can probably try to guess that, oh, they probably use the same password again and compromise that as well. So DPAPI, basically internet browsers like Microsoft Office like that will save credentials on a file. And if you get access to a computer and they have them, you can decrypt them and gain access to it. Yeah.
Okay, it's encrypted on the file.
Yeah.
How do you decrypt it?
It's because it's actually publicly known
That's publicly known.
how to decrypt it. Yeah. Microsoft. Yeah.
So it's publicly known.
How to decrypt it. Yeah. As long as you, but you need certain privileges sometimes to run them. So if you need like administrator sometimes to go and decrypt them. So as long as you have
access the role of an administrator.
Yeah. So sometimes you might need to be administrator to access them, but if not, then you can just access them like for free. And I'll show you an example of that in a bit. But yeah, I'm just going to a high level overview of like everything, and we'll go into how to attack all of these in a second. Okay, so this one's a little bit weird. If you did the homework, they talk about hashes. Basically, it's a way to get plain text credentials. So plain text credentials mean just like human readable words. So if you say password, password's a word that you can know. Basically what hashes is you can get a plain text credential, like human readable like letters and words. You throw them into an algorithm. It basically blurbs it up and then outputs it into a password hash. So basically the original password is now like blurbed up and it's different. And they do that for security basically. So this is getting to like cryptography, data integrity, stuff like that. So they do this to make sure that people just don't have plain text credentials. They have these hashed passwords so that they're not easy to go like decrypt and stuff like that. And Windows actually uses two types of hashes. It uses NTLM and NTLM v2. Basically, you don't need to know like exactly what they do. It's just a hashing algorithm that they use. And yeah. So basically they're generated from users' passwords and then it's better than using plain text. And the reason why I mentioned these is that, so I mentioned that there's two different types of hashes. If you were to somehow get access to NTLM, not NTLM v2, this is an older version, obviously, because it's not v2, it's the older one. You can actually go and get the hash and use that as a password. So even if someone had a really complex password, if you were to get the hash of the password, you can use that instead of the password. And I'll go into that in a bit. Basically, it's just a way for you to obfuscate a password. It's more secure in really simple terms. But if you want to get more into it, look into cryptography because it's a lot. And people who are in CS probably will know more about it, but I'm not a CS major.
Also with like hashing, the big thing is that you can't like undo it. Like it's made so that you can't go backwards. It's a one-way, it's a one-way process. So you're probably wondering that how does the computer authenticate a password, like a plain text password to a hash? It does that by passing the password that you just put in through the hash and then comparing those two hashes. Because if you put the same thing in, then it'll output the same hash, right? So it's verifying, it's authenticating by comparing the hashes, not comparing password to hash. Does that make sense?
Yeah, like let's imagine that your password is password, right? And this hashing algorithm, if you were to put that password called password into the algorithm, let's say it outputs 1, 2, 3 for what, like, just for like simplicity, right? So the computer has the hash stored on the computer, right? And it says, okay, my password is 1, 2, 3 hashed. So if I were to stick the password, if I were to type in my password, it'll go into the hashing algorithm again and be like, oh, it's 1, 2, 3. What was the password in the computer? 1, 2, 3 hashed. It's going to compare the two values. If they're the same, then it logs you in. That was like an overly simplified version, but yeah, the hashes are extremely long. They're not like 3 digits.
So hackers, they take like regular passwords you can type in and they convert it into like a string of numbers?
Yeah, like letters, numbers. Yeah.
Okay.
So students will be taking 133 over here. You have like a whole section on hashing. So it's like way more about progress.
Yeah. And I'll show you an example of what they look like in a later on. But yeah, so the hashing algorithm they use is like MD4 hashing algorithm, which is honestly pretty shitty and not secure at all. The reason why is like some hashing algorithms, they use like more letters, numbers, their variety is like very different. So it takes longer to basically figure out how it works. And then obviously they thought Windows was, or basically Microsoft was smart and like, oh, that sucks. We're going to use a more secure hashing algorithm. So now they use this HMAC MD5 based hashing mechanism, which is basically just better resistance. And this password cracking thing, we'll talk about too later on. Any questions? So these are just the two hashing algorithms they use, MD4 and MD5 HMAC. Okay, cool. So we're gonna talk about common protocols. These are like basically the ones, if you're running an Nmap scan against a Windows server, these are probably the really common ones you see. And I handpicked the ones I think are the most important to look at, but I just wanted to put this here on the slides in case you wanted to see my thoughts about the most common ones you'd see. Okay, so the first one, which is 80.443, remember, this is a, does anyone know what this is? These two ports?
One's for website, and then, I think 80 is for website and 443 is for browser.
It's the same, yeah. So 80 is HTTP, so it's the non-secured version. So 80 is HTTP, 443 is HTTPS. Yeah, so it's hosting a website basically. If you see those two numbers, it's most likely hosting a website. So just like Linux, Windows can also host things, right? It's a server, Windows server. Wow, crazy. So basically you can host websites, web applications, whatever. But interesting enough too, it can also host more than just that. So IIS is basically a platform that can host web applications, but can also host like FTP, so file transfers, that's on 21, SMTP, that's for mail. It can do those. And the important thing to know is that when you're on Windows, the programming languages that you might be running up against, because we mentioned before the rev shells, right? How do you know what code to run? It runs ASP.NET, which is basically Microsoft's own programming language. There's PHP and there's Python. So if you're able to run code, you should try to run it in one of those three languages because it might work. Any questions on that? Basically, IIS is just a platform to run websites, shit like that on Windows servers. Okay, cool. Now there is Kerberos. It's another authentication protocol. Wow, there's so many authentication things about Windows. It's ridiculous. But basically, this is for accessing like services that are running on a Windows server. So let's say like, I don't know if it's like that here. You can probably correct me. Are you guys able to access like your own like little file share on like libraries? Like you have like your own like name where you can have files and stuff like that in it.
On your, like just your main computer?
Yeah, like here at the college.
We don't have that, but it's like, I see in the past versions of Windows, you used to see a network location where it had a little green dots in there. But now what they do is like, they do have something like this in the background, but they have their own, users have their own space, which is like their username, which is mapped to their.
Okay, got it. Yeah, yeah. So basically, how a lot of schools tend to do it. I went to Mount Stock, and this is how they did it. It's basically when you're to like log into your own like school account at like a library or whatever using their own computer, and you want to like access your files, they'd have a file share with your name on it. And it's basically your own little share where you can have like your files, whatever. No one else can access it. So the way that Windows goes and authenticates you are who you say you are to access that is Kerberos. So basically anything on a Windows server that you, well, not anything, but a lot of it on Windows server that's being hosted, it'll use Kerberos to authenticate you to the services that they're running on the server. Does that make sense? So when you authenticate like directly to the computer at first, it might use like SAM, NTDS, but when you're accessing services on the server that they're hosting, it'll use Kerberos most likely. Does that make sense?
So the school use Kerberos?
They might. I have no idea because I'm not IT, so, but they might. But yeah. So this is a really important protocol. So I'm actually going to go and talk about the whole process of it. And it might look absolutely daunting at first, but trust me, it's not that bad. So hopefully I explain it well enough that it makes sense. So basically the main thing is you need to understand these 4 steps right here. This last step is basically the service you're trying to access, but these 4 right here is really important because it can be used as an attacker. Okay, so the first part right here is this KRB AS rec. Basically, what this is saying is it's a Kerberos authentication request. So you can see AS, which stands for authentication server. It's basically saying this Kerberos protocol, you're trying to authenticate to this server right here. You're making a request to it. Basically, all you're saying is that the end goal of this thing is you're trying to access some sort of resource, right? You're trying to access a server or some service that you're trying to access. So basically, the first thing you do is you talk to this KDC, which is a key distribution center or Kerberos key distribution center. And there's 2 components in it. There's this authentication server, and there's also this ticket granting service or server. So the first step of it is you need to validate this authentication server needs to actually validate you are who you say you are, or even like this person. So the first thing you do is you pass over your credentials to it. So you say basically like, hey, I'm trying to log in. And if it validates who you are, it'll send you back something, which is basically when you send over data to it, the data you're sending over is basically your identity and a timestamp of what you're trying to do. So when you're using Kerberos, it's very time sensitive. So if you get like errors trying to log in, it might be because your time is off on your computer, because it basically has a way to identify who you are, like your user identity and timestamp. Basically, it sends a request sending those 2 things, a timestamp and basically a way to identify yourself. That's the first step. Does that make sense? Okay. So now the second part is, let's say that actually went and validated who you are. So check the timestamp, it checked your user identity. It's like, okay, cool, you exist as a person, right? Basically what it'll do is it'll give you a TGT or a ticket granting ticket. It's super convoluted. But basically this TGT is basically a ticket saying you are validated. You are who you say you are. I validated who you are. And basically this TGT will be used later because now it got sent back to you. And this TGT will be used with this third one, this TGF, which is a ticket granting server. And so basically like the TGT, if you're wondering what's in it, it's basically the encrypted user password. Also, it contains like your identity, timestamps, session keys, bunch of crap. Basically, you get a ticket and the authentication server validated who you are and it said, okay, you are who you say you are, here's a ticket that you're validated. So now basically the next part is you validate who you are, this first and second one. The third one now is, okay, you validated who you are. What do you want now, right? So you're trying to go and you get another ticket to access the service, right? Because the end goal is you're trying to access some sort of service that's running on the server. So from here, this ticket granting server will grant you a ticket to access a service that you want if you properly validate yourself. So basically you have a ticket, right? You said, oh yeah, I got it. I said who I am before. This authentication server authenticated me and gave me a ticket that said, I am who I say I am. You're gonna get that ticket and send it over to the TGS, the ticket granting server. It'll validate you and say, oh yeah, you got a ticket from the authentication server. Oh, that's good. Okay, cool. Here's a ticket for whatever service you want now. This fourth step is detrimental and you don't have to read all of the big blob of text. It's just there in case you want to read it later. But basically the fourth step is, so to recap the third one, you give the ticket granting server your authentication. Like you said, okay, I am who I say I am. Give me access to what I want access to now. If it validates it, I'll say, okay, cool. Here's a ticket to the service that you want now. And the important part about this ticket is it's called like a TGS ticket or service ticket or ticket granting ticket. Basically, the important part in here is that these services that run on servers, they're usually administered by IT admins. And these services, believe it or not, actually have credentials inside of them. So if you're to actually go and look at all of like the network traffic happening, at the very last step, the fourth one, where it gives you a ticket to access the service, there's actually a encrypted password in there that if you can decrypt it, which we'll go into later, you would have access to a service password, essentially, because it's just in the packet from the network connection. Any questions on that? So this fourth one, it validated who you are and gave you access, a ticket to go and access a service. And basically this fifth one, the fifth and sixth one is you're taking that ticket from here, the ticket granting server, because it gave you a ticket to access a service. Because to go over really fast, the first and second one, they give you a ticket saying you are properly authenticated. Here is proof that you are who you say you are. The third and fourth one is you give that ticket granting server a ticket and said, oh, you have validation of who you are. Here is a ticket to go and get the service that you want access to now. You take that ticket that you have for the service that you want, and you give it to the server. The server will say, oh, you have a ticket for the service that you want. Here is the service that you want. So if you're accessing the file share, it goes through that whole entire thing just insanely fast. So that's what it does.
So like, if I was like part of like, let's say accounting team of a company, so the first step is logging in with my company name, second step is proving that I'm accounting, and third step is getting my spreadsheet.
Kind of, yeah. So like the first step would actually, like the first two you mentioned would actually be the first step in total.
Oh,
So
okay.
like you saying, oh, you're from accounting, this is my username, this is my password, that'd be the first step. And then the second step is what the server does. It basically says, oh yeah, you are who you say you are. Here's a ticket saying you are who you say you are. Imagine like they had like all of your IDs, right? So imagine like you didn't have an ID walking in and you need an ID to get access. Like the way I like to like describe it is like, imagine like a fair or something, right? So imagine that to get access to play games, you need a ticket with your name on it. So you go up and be like, oh yeah, I want to play games. Like, well, you need a ticket first with like your picture on it. You say, oh yeah, this is who I am. Like, oh, this is who you are. Here's a ticket with your name on it, basically validating you are who you say you are, right? Well, now you try to go and access the game and say, oh, you need a ticket to access this game. Go over there. This ticket granting server will give you a ticket to play the game. You go over there, you talk to them. Hey, yeah, I want to play this game. They told me I need to get a ticket from you. You say, okay, show me that you are who you say you are. You give them the ticket with your name and whatever on it. They'll say, oh yeah, that's you. They give you a ticket to the game. You walk over to the game, the fifth step. You say, hey, I have a ticket to the game. They say, oh yeah, you do. The sixth step, they give you the game. That makes sense? Overly simplified, but yeah, that's basically what it does. Okay, cool. These ones are a lot simpler. NTP. So I mentioned, the reason why I mentioned this is Kerberos is very time sensitive because I mentioned that when you send stuff over to it, it has like your user identity and a timestamp. The timestamp is an important part because if your time is off, it might not authenticate you properly because like, oh, the time is too different. So NTP, network time protocol, is basically a way to synchronize your time. So if you ever go and like your time's off and then you go and like, I think like Apple has their own, Microsoft has their own, it says like ntp.microsoft.com. It's basically their own way of synchronizing time to their own clock. So if your time is ever off and you're syncing to something, it's network time protocol. And I mentioned it's important for like Kerberos, stuff like that. LDAP, basically, I mentioned before that Active Directory is used because it has a bunch of like organizational units. There's a bunch of like objects and stuff like that. Because basically like users, computers, accounts, stuff like that, they're all objects in Active Directory. And LDAP is a protocol, is a way to go and access and manage these things. So Active Directory actually uses LDAP in the back to go and access and manage all of these objects. That makes sense? Okay. SMB, this is a really important one. So SMB, which is on port 445, is basically a protocol that's used for file and print sharing. So we mentioned before that, like, oh, if you're at a school and they have like a file share for you, that's using SMB, which is a served message block. Basically, all it is like a file share. The file share or printer sometimes. That's it. RDP. RDP is basically a remote desktop protocol. So if you're to go and like have, if you wanted to like remotely access a computer, like your Windows computer from somewhere else, you would have this port open, which is like 3,000 something, I can't remember exactly. Basically, it lets you remotely connect to a computer over network. That's all it does. So it's like SSH on Windows, but you actually have GUI access, so you can move around a desktop, open shit, whatever you want. Okay, the last one is WinRM. This is mostly used for administrative people, but also can be used by attackers. And the reason why is it basically lets you manage Windows hosts remotely, but it's basically through a terminal now. So rather than having GUI access, this is basically through a terminal. And it's used by administrators a lot because it can basically scale out. So you can run multiple commands on different hosts using WinRM compared to remoting in with RDP and like using the GUI and trying to do things manually like that. Does that make sense? Anyone have questions on anything? Yeah.
I don't have any questions actually right now.
Okay. Okay. So I'm gonna talk about useful Windows tools really fast. This is a really important one. So basically, Bloodhound is a tool that uses graph theory. I have no idea. Does anyone know what graph theory is? You computer scientists. Yeah. Okay. I have no idea what that means. basically, I mentioned that Active Directory has a bunch of objects, right? So users, groups, things like that, right? So if you get onto a server, how do you know what to look for, right? Because basically the main thing is that when you're on a computer, we mentioned privilege escalation. You want to go and get access to someone. And when you get initial access, you want to move your way up and get to the highest level, right? How do you know where to go in Active Directory? If someone said, oh yeah, I'll give you initial access to Fullerton College, good luck. You have like 10,000 students, something like that. How do you know who has access? There's like IT, there's HR, there's so many different people. How do you know what to go for? So Bloodhound is used because basically it uses graph theory, whatever that means. And it can basically go and identify like users, groups, stuff like that. And based off what you got initial access to, it can find a way to the highest point that you can get to. So imagine that Nisir was the first one that I compromised or that you compromised. And imagine that I was like an IT administrator and I was super lazy and gave myself like permissions to a lot of things. And for some reason, Nisir also had permissions to the same group that I was a part of. And then so he is like the main administrator for something, right? And me and her are in the same group. Basically what this thing can do is that if Nisir is compromised, it can find that Nisir has access to me and I have access to Sohi, and it can be like, oh, go from here to here to here to fully compromise everything. And it does that all on its own, which is really cool, and uses graph theory, again, whatever that means, to do that. So yeah, it can basically identify complex attack paths really fast. I mentioned that in Active Directory, it can get really big with tens of thousands of users, objects, stuff like that. So it can make things really simple. And yeah.
So it would sort of find an attack trajectory for you.
Yeah, exactly. Yeah, and I'll show an example of that in a second. So you're probably wondering, how do I even run this? There's two ways to run it. You can remotely run it if you have credentials with this Bloodhound Python. This is kind of how it looks like, and it shows you like there's like one domain on 2 computers, 31 users, 75 groups. And then if you have access to the server itself, so you got like a shell on the Windows server, you can use Sharphound. It basically does the same exact thing too. You won't need to use this for the tryouts or anything, but it's really important to know because it's used in industry a lot as a penetration tester. Any questions on that? Cool. Okay. So I'm a visual learner, so I like to go and visualize things. So this little scroll right here is basically the initial person you got access to. So this SVC alfresco person is the initial person you compromised. So when I said, oh, I compromised Nasir, this is kind of what it looked like. And the interesting thing about it too is it'll basically link together what you have access to. So saying this SVC alfresco person is a member of a group called service accounts. And within that group, there's a subgroup called privileged IT accounts. And within that, there's another group within that called account operators. And then we have this generic all thing. If you were to be on Bloodhound and click on it, it'll show you how you can go and abuse these certain things. But basically what this generic all means is that you can basically go and add yourself to this group. So this SVC alfresco person who's a part of all these groups has access to go and add themselves to this Exchange Windows permissions group. And this little green thing basically says that you can compromise the whole entire server if you get to this point. So if you can add yourself to this group, you compromise absolutely everything is what it basically found from that. Yeah.
So what it means is if you get to have an ID address in a domain in the Active Directory for Fullerton College, you can actually use Bloodhound to traverse every
object
group you're in, and then see what other groups are linked to that.
Yep.
So user itself has access to all of that.
Yeah. Yeah, so all the objects itself can already be identified. You don't need administrative privileges at all. As long as you get some sort of user, you can see what's on it. Yeah. So yeah, it makes things really, really easy because if I were told to do that on my own, I'd be like, I don't know how to do that. But this makes it a lot easier to do.
But the idea that you can add yourself to this subgroup is a poor configuration, right?
Yeah. Yeah. So the thing about Active Directory is the reason why I love Windows so much is for Linux, you'll notice that for these CTS stuff like that, they're purposely vulnerable. Someone did some terrible code for it. For Windows, the smallest misconfiguration can just absolutely screw you. So the fact that this group right here, account operators, can add themselves to that group was that small thing that completely took over the server. So yeah, that's pretty detrimental. This is a small misconfiguration someone made. And Bloodhound found that and made a path for you to do that. Any questions on that? Probably. Okay. Another tool is Impacket. Basically, it's a collection of Python classes to go interact with network protocols. Basically, all it is that you can go and interact with like basically Windows protocols. So I mentioned like SMB, LDAP, NTP, all these things. Impacket is basically a way on Kali for you to interact with them. Because if you didn't, you can't just use Netcat. Netcat's gonna be like, how the hell do you even do that with Netcat? So Impacket is basically a Python class that can go and interact with it for you. And it's like super well documented. So if you have any problems with it, it's like well documented exactly what to do. And there's a lot of guides online about how to use Impacket. And there's also another tool that is basically built on top of Impacket and makes things even easier. And it's my favorite tool ever on Windows that I'll go into. But yeah. So some things you can do with Impacket, and I'll get into some of these things later on, is there's like relay attacks, just pass the hash, cover roasting, all these things. I'll get into exactly what those are, but just some capabilities you can do with Impacket. Any questions? I know I haven't gone over it yet, but I'll go over it. Any questions on that? Okay. Mimikatz. If you mention Mimikatz in an interview, they will probably really like you because it's one of the most used tools that adversaries use on Windows. Because you mentioned before that there's these certain ways to go and like authenticate you, right? There's SAM, NTDS, there's LSAS, stuff like that. Basically, Mimikatz is a tool that you can use that when you compromise a computer, you can go and actually just dump those credentials from it. It'll automatically do that for you. So that if you have access to SAM, NTDS, whatever, you can specify what you want access to, and then it'll just spit out all the credentials for you, just like that, because that's what the tool is made to do. Any questions on that? It just spits out credentials, essentially, if you get access to something. And then I'll mention what this pass a hash thing means later. Because I mentioned before that you don't need passwords, you can just use hashes. And that's really, really powerful. But yeah, so you can use Mimikatz, dump credentials, and you can start trying other people's passwords. Maybe you can log into like an engineer or something like that, just off Mimikatz. Yeah.
A question about what you said regarding not using passwords and using hash rates.
Yeah.
I do get the password authentication process doesn't necessarily compare a password, it compares a hash.
Yeah.
But why is it more convenient for us or like more accessible to get a hash versus getting a password?
So the reason for that is, and I'll get into that, is that, so let's imagine that like for some reason, like you don't have any plain text credentials, right? So you don't have a password that you can actually read. They're all hashes. So usually most of the time what you'll need to do is crack them, and I'll go over that in a second. But cracking them basically is you need to go and basically have a long list of like known passwords, and it'll go through the hashing algorithm and compare the two, right? So on the computer, like on the server itself, it has the hash of like your password, right? If I was a hacker trying to get your hash, basically what it'd be doing is I'd give it a bunch of passwords, and it'd basically be like, okay, I'm gonna throw this password into the hashing algorithm. Is the one I just used equal to the one that's on the computer? No, try the next one, try the next one, try the next one.
Just brute force.
Brute forcing, exactly. It's brute forcing each single one. That's a lot of time. And I mentioned before that the better encryption that they use, the longer it takes to go and try to brute force that.
Right.
But with Windows, if you have MTLM, just a normal one, you don't even need to crack the hash or anything like that. That's what you usually need to do, right? You need to like have the actual like plain text credentials. For Windows, you don't need that. So someone could have like a complex password, but if you have the MTLM hash, it doesn't even matter. You don't need to crack that strong password. Because remember, when you're brute forcing it, you're using known passwords, like a list of known passwords. What if it's not on the list? Then you're screwed. But if you have hashes with MTLM on Windows, you can just throw that in and it'll work and authenticate you.
So then in that situation, the strength of the password would be irrelevant.
Yeah. So I think if you use over 25 characters, it switches to NTLM v2. And NTLM v2, you can't just grab the hash and log in with it. Only NTLM v1, the older version. Yeah, if you're being secure, yeah, longer password. Or you, if you're like the IT administrator, you can actually force NTLM v1 off and just disable it completely.
Oh, okay, so you can do it manually.
Yeah. But yeah, that's Mimikatz. So my favorite tool I mentioned is CrackMap Exec, or CME. Basically, they call it like a Swiss Army knife for pen testing networks. The main great thing is that it uses like the most common protocols that you'd want to go and assess, which is MS SQL. So that's Microsoft SQL, that's their database. WinRM, we mentioned that's Windows Remote Management. So that's like your way to accessing LDAP, which is like the lightweight directory access protocol. So that's your way of like accessing objects in Active Directory. SSH, which you guys all know by now, it's your way of like promoting in through Linux. SMB, that's the file share protocol. RDP, which is the remote desktop protocol, that's your way to get GUI access to a Windows server. And then FTP, which is file transfer protocol. That's like your file share on Linux. So basically with CME, if you have credentials in one form or another, you can go and assess all of these protocols just with one tool, which is really great because rather than having to go and learn like 12 different tools to access these protocols, you just use one and it has a bunch of capabilities to it. And I mentioned before Impacket, which is basically a library, a Python library of ways to access these. For Impacket, you have to use like 12 different files, 12 different like Python libraries to access these. CraftMap Exec just uses this one tool and it has all of it already built into it. It's like basically built on top of Impacket. So if there's anything you can do with Impacket, you can do a CME and it's just one tool that does everything for you. So that's why I love it a lot. And also it can even work on Linux too. So yeah. So I mentioned that I love it so much. So what exactly can it do? So it can do enumeration. It's basically enumeration meaning like it can go and start to go and like look for things in it. So let's say like you had like a username and password and it had a bunch of like file shares, right? It can go and look through all of them and tell you, hey, yeah, I found all these files for you. And you can just go and look at it. But rather than having to do it manually with Impacket, it'll just show you all of them. You can test to see if you can authenticate. You can do command execution too. So if you had a username and password and it says, I don't know if you can see it right here, but on the very right, which is like administrator and it says like pwned in orange, it's like the fourth line. That basically means that you can run commands. So rather than like, if you had a username and password, you're wondering, well, how the hell do I run commands on this thing now? CME just does it for you. It can run commands all you want. And then it can spider share. So I just mentioned that if you have a share, it can go through and find each single file. Password spraying. So let's say that basically password spraying is a technique used to, let's say like you found that you're like attacking Fullerton College, right? I always say attacking Fullerton College. Let's say that you like were like walking by and you heard like at a meeting, they're like, oh yeah, new interns here have the password Fullerton College 1 exclamation mark, right? What you can do is you might know the naming scheme of Fullerton College, right? Maybe it's like your first letter, last name at fullertoncollege.edu. If you know that and you know that there's a password someone's using all the time, basically what password spraying is you take all of the list of people and you use that password against every single person. That's password spraying. Does that make sense? Basically, yes, spray and pray. Brute forcing is another one. That's basically you get one person and try a bunch of passwords against one person. Password spraying is a lot quieter because you're only trying to log in once. If someone tries to log into like your Instagram and Twitter a bunch of times, what happens? You get an email saying someone's trying to log in. So password spraying is a lot better. But yeah, I can do a ton more too. But yeah, that's CME. Anyone have any questions on that?
Do we have to know what the origin thing means?
No, I was just showing this. So basically, what this one's doing is it's enumerating DNS, so your domain name system. Basically, domain name system being the domain names. So someone with a username and password was able to identify there's different domains in the server that you can access now. Maybe you didn't know that before, but now you do with CME. So now your attack vectors are even more. Maybe you can go and attack a different domain. There's a whole new server that you can attack just based off that. Any questions on that? Yeah.
Just kind of curiosity, who makes these things?
Just like security researchers. It's just all open source. Yeah, it's all on GitHub. Yeah.
Why is it repeating like everything, like the same line on the left? Like it's the same thing.
Oh, so the 192.168.1.105, that's basically saying who your target is because we mentioned password spraying, right? So what if like you can even do multiple targets too, right? So let's say like you had multiple IP addresses, you can mention, oh, I want to do it against like 10 IP addresses. So basically that's there to specify which one it's attacking. But in this case, it's just one. So it's just doing the same one over and over again. But if you had like 10 of them, it'd be like 192.168.1.105, 106, 107, 108, stuff like that.
What command is the -u?
-u, that's user.
Oh.
So basically it's saying it's saying CrackMX exec, which is the command. What protocol do you want to use? SMB, so file shares. The IP address you're trying to attack, 192.168.1.105. The user, administrator, -p is the password, so whatever that says. And -M is module, and it says enum DNS, which is enumerate DNS. So you're trying to go and find information about DNS. Yeah. Any other questions?
Yeah, and when you like SMB the DNS IP address, it's basically like the lab of your own.
This one,
Yeah.
you're like your own lab, or what?
I mean, is it like a website?
And this one is it's like their own lab, yeah.
Okay.
But I mean, it could be an actual company too. So yeah. Okay, the last two is Evil WinRM and RDP. So we mentioned these two are basically ways for you to go remotely access Windows. CME actually already has that. I mentioned WinRM. So if you wanted to do stuff with WinRM and RDP, CME already does that. But if you want to just use it on its own, it's here. So Evil WinRM is basically a way for you to get a shell if you have access to a username and password. And then you can basically use that to access or get access to a server just using username and password with WinRM. So that's all it does. And then RDP, the remote desktop protocol, if you happen to see that port open on a Windows server, you can go and use credentials and use either X3RDP or RDesktop. These are both commands on Kali Linux. Or if you have your Windows computer, you can use the remote desktop connection app to interact with it as well. Any other questions on that? Basically 2 ways to remotely access stuff. Okay. Kub roasting and ASF roasting. I think I have time. Let me make sure. How many slides am I on? 55. Okay, I can do this. I trust myself. Where's my mouse go? It's over here. Okay. So we mentioned Kerberos before, and the reason why I harp on it so much is you need to understand that to understand this, right? So basically, Kerberosing is a way to go and get the hash password after the TGS rep happens. So remember, that's the 4th step. That's when you said, oh yeah, here's my ticket, I am who I say I am. And then they say, oh, here's the service that you want. Here's the game that you want to play. That game that you want to play has a password on it that you might be able to go and decrypt essentially. So that's what it is. So that's going through the whole process. That's Kerb roasting. ASREP roasting is basically the same thing. But what happens is, I mentioned that for step 1 and step 2, you had to go to the authentication server and validate who you are, right? So I walk over there, I say, hi, I'm Bryce. This is me. This is my timestamp. And then I say, oh yeah, you are Bryce. Here's you, right? ASREP roasting is actually a configuration on Windows Server where you say, I don't want to authenticate you. I'll just give you it, right? So that first step where it's like, oh, I am who I say I am, and they give you a ticket validating you, they say, I don't care who you are, here's a ticket. That's basically what ASREP roasting is. It's basically the same thing as Kerb roasting, where that 4th step is you're trying to get the password of the service, right? Because they give you a service after you validate who you are. This one is basically like voiding step 1, step 2, and they just give you a ticket automatically. That's just a configuration you can set on Windows. Why? I don't know. But
Without them having to like ask you who you are.
yep, they just give it to you.
So it's just like a weakness in the authentication.
Yeah. So basically, if we were to go back to
It's called ASREP
roasting. Yeah, and the reason why it's called ASREP is if you see right here, you see how it's ASREP, right? So the first 2 steps for here is validating who you are. Basically, these first 2 steps is just null and void. You basically just instantly get identification. And I say, okay, with that identification, you can get access to a service, right? So basically, this first 2 steps is non-existent for ASREP roasting. Why does someone configure it that way? I don't know, but that's a configuration someone can have on Windows.
Why would they not just do that first step, the ASREP roasting, instead of going through all 4 of them?
Yeah, I don't know. I think there is like legitimate reason, but that is a flaw if you were to enable it. That's just a misconfiguration you can have. So you can have.
Referring to why don't you get the ticket for accessing the server before authenticating?
This is what, yeah. So basically, the first 2 steps is like it's like user authentication, right? For ASREP roasting, it basically will give you a ticket regardless of who you are. It won't validate you. Yeah.
Yes, but then that ticket, does that have your own? Does that ticket have a header that says like you are this person, or does that have the user?
I think it does have. So basically, if you give like a username and like a null password, there's nothing in it, it'll just give it to you anyways. But the thing is that it doesn't matter. So I think the fifth one actually does validate you. So but for us, that's not what we care about. We care about the fourth one, which is the encrypted service password that's in there. So we basically don't care about the fifth and sixth one. But I think if you did try to request a service at that point, it wouldn't validate you properly, I think. But yeah, I think I have another picture over here that goes over it. Yeah, so basically, I don't know if it's kind of hard to read, but this is Wireshark. Basically, Wireshark is a program used to basically see all the network traffic happening. So for here, basically what I did is I accessed some sort of service I wanted, right? And you can see, it might be hard to see, but it's going through this whole process. So this first one right here is the ASREC. Then there's the ASREP, there's a TGSREC, TGSREP. So it's going through this whole process. And if I click here on the TGSREP, this fourth one right here, where it's giving me a ticket to the service, if you look here, there's this encrypted part and this cipher right here. If we were to go and grab this whole entire thing, that's the hashed password of a service that we're getting access to. Does that make sense? It's kind of just visualizing what actually has happened. You can see all the network traffic. And this is a protocol, right? It's using Kerberos, the protocol.
Oh, so you can see that using Wireshark.
Yeah.
If I install Wireshark right now, would I be able to see all the network traffic
Happening through this,
knowledge?
you see it through EDU-RUM, whatever network you're on, yeah.
But I'm not allowed to do anything because my API was shown.
No, you're just listing the traffic.
So can I grab this password from the simple traffic and just try it on something?
Yeah, but we're gonna get into why this is hard. So what do you do with this, right? We mentioned it's encrypted, so we have to crack them. And so I mentioned cracking passwords or cracking hashes is basically like a way of comparing things. So the server itself will have the hash password, and when it'll basically wait for the correct password to come in, because so you as a user will type in like a human readable, just plain text password. When the server is waiting for the password, it's waiting for a hashed password. So it takes your password you typed in, goes through that hashing algorithm, and then that hashed password, it'll compare the two and say, is this password equal to each other? Yes, log in, right? So I mentioned before that when you're trying to crack these passwords, the most common thing you do is you use a commonly known list of passwords, and the most known one is called rocku.txt. But basically, if that password is not in there, then you're kind of screwed. There is ways to do it manually without knowing the password, but the thing is that the longer the password is, the more time it's going to take to go and crack the password. And the resources that actually uses to do this is like GPUs. So some like penetration testing companies will literally get like 10, like 4090s for graphics cards, because it'll actually go and run these like cracking faster. Does that make sense though, of how like cracking hashwords, like cracking password work?
Just to add or simplify it a little bit, but it's just running an equation. So the graphic card can actually run the equation 1,000,000 times in a single millisecond. So you just are doing some, like you can say it's a simple mathematical function where you multiply every number by 2. And that's what your hashing algorithm is. So when I say 1, 1 to you, and we want to hash, it would be 22 rather than 11.
So if you know how the hash is.
Yes,
how
if
the
you
algorithm
know
is
how
hashing
it's
it,
done,
you can
you can actually do that. But the problem is it's super tough because you're studying hashing. There's like some keys which are involved. So it's like right now, technically it would be impossible for you to like do the same thing or go from the hash back to the string.
That's why you just compare. So you go through it, it spits out something, and you compare the two.
So then in that case of comparison, you don't need to know what the actual hashing algorithm is.
Yeah, you're just using it, and then whatever it spits out, you're just trying to compare the two. Yeah, that makes sense. And I'll give an example right here. So okay, well, you know that. Is there a tool for it? Of course, there's a tool. So basically the main thing you'll be using is Hashcat. You might also hear like John the Ripper. That's another one too. They both do the same thing essentially. I like to use Hashcat. Basically it's an open source password cracking tool. It'll basically compare the two hashes and do that. And I mentioned before that the most common way to crack these hashes is to use a known password list. So on your Kali Linux, there's actually already a file there for you called rocku.txt. It's very well known. And it's here, user share word list rocku.txt can be found there. Any questions? That's all Hashcat is. It basically just does what we mentioned before. Okay. So let's give an example. So let's say that we're actually running Kerberos and we get a username and password and we get this gigantic long hash here. Makes no sense, right? So this is a service ticket, right? We mentioned on step 4, there's like an encrypted part of it that has a big long hash. This is it right here in its big long form. So does everyone see that? How that works? Everyone see it? Cool. So basically we get that. And now basically Hashcat has the ability to go and like basically get a list of like known words, so like human readable words, and throw it into this hashing algorithm. Well, how do you know what hashing algorithm to work, right? Like to use, because there's multiple hashing algorithms. There's like MD5, there's NTLM, there's MD5, MD4, there's like hundreds of them. How do we tell Hashcat which one to use? Well, you can go to the website right here, example hashes right here. So hashcat.net, wiki, docu.php, example hashes. And it's basically a list of a bunch of hashes they have, and that gives you example output. So what I tend to do is I'll look at the very beginning of the hash, and it's kind of hard to see, but it has a $sign and it says KRB5 TGS $. I'll go to that site, Control F or Command F, and I'll search for that $sign KRB5 TGS $. And the first thing I see is this one, Kerberos 5 E type 23 TGS rep. That makes sense because the 4th step is the TGS rep, right? And it is Kerberos. So this is probably what it is. And it says on the left here what mode it is. And it's the 13,100th one. So noting that, basically all we need to do is tell Hashcat the mode we want to use, which is 13,100, because that's what the Kerberos one is. We tell it what our hash is. So basically we got that hash and put it into a file. We can copy the whole content of it and put it into a file. You can call it like hash.txt. That makes sense? You just grab all the contents of here and put it into a file called hash.txt. And then the last thing you do is you reference what word list you want to use. So you mentioned Rocky.txt is a big list of commonly known passwords. So that's what I'll be referencing when it's comparing the passwords to each other. So we run it, and after 1 second, it finds this password. I can't even read it, but it finds a password for a service account. So now you can grab that password and log in as someone, do that. So basically, just because you read that Kerberos, that last step, you're able to get access to a service account based off that, and you crack the password because it's weak. It's well known. So the way against that is probably wondering, how do I prevent that? Have a stronger password. So like 8 to 10 years ago, this used to be the quickest way for a company to get compromised. It was like super fast. You'd go and Kerberos them, and then you'd be like, yep, I got your service account. It has administrative privileges. You're done, because now you have access to everything. You're an admin on the server. You're just done. But what people did now is when they make service accounts, they'll make it like 80 characters long. How do you crack that? You spend years waiting for it to try to crack it. I mean, yeah, no one's going to do that though. So they made the passwords just really, really, really long to make it so it's harder to Kerberos it. But for like some like CTFs and stuff like that, they'll make the password weak so that you can go and crack it like that. Any questions? Okay. All right, so I mentioned before, SAM, NTDS, LSAS, and DPAPI. So how exactly do you go and abuse that? So basically, I mentioned like all of these things can go and have like databases of stored account information. And I actually have like little walkthrough videos of what all these are doing, and I'll show you like how to compromise it. So where did it go? That's right here. Yeah. What? Nothing back here. Okay. So basically, for this one, I'm going to be attacking SAM, and basically the way to go and do this is I think this is the right one. Is this the right one? Oh yeah, so I mentioned before that SAM is actually located as a file on the computer somewhere, and it's actually, you can find it in the registry. So we can see here there's like 2 security system SAM ones. So if you get access to these, you can go and throw it back onto like your Kali machine by like basically setting up a web server on the host and then sending it over to yourself. So basically I'm setting up on my own computer, I'm setting up a web client to basically get access to something. And then I basically send over the file to myself. And now on my Kali machine, I have the SAM security system files, these three, and I can go and use the SAM dump2 file and basically reference, it says I need the system file and the SAM file to get it. So if I'm able to go and extract both those files, you can see I have these right here, which is basically the hashes. I mentioned before, these ones right here are NTLM v1. So we don't know what the actual password is, right? We can go and try to crack these, but we don't need to. If we have NTLM v1, we can just grab right here when my mouse is all the way to here, copy that, paste it, and log in as administrator. If we don't need to know the password, you can just log in like that, just by grabbing the SAM and the system file off the computer. That makes sense? So if you're able to extract those off the computer, then you can go and dump the hashes of that. Nothing else is required. Okay. Okay, that was SAM. NTDS, which is the Active Directory version, basically does the same exact thing. And I'll show that in a second. Let me open it up. Huh? So basically with this one, basically what you do is you create like, you're copying out all of like the system security and the NTDS out of it using this command right here. You really need to know what it does. Basically, all you need to know is that it dumps all three of those files. So system security, NTDS. And then when you go and basically transfer it over to your computer right here. So this is me transferring it over to my computer. I get access to ntds.dit, which is the file that we need. And also we need access to the system and security file. So I have access to those three as well, or those two. And basically if I have access to those two, I can run this in-packet secret sum. We mentioned in-packet before. Basically it can go and get all this NTDS and the system file, and it can go and extract the NTLM hashes of all of the accounts on an Active Directory. So all of these accounts right here is what we have access to on Active Directory. And I actually show an example. So basically, if we go and run craft exec on the bottom and paste the hash of the administrator. So we don't know the password, right? We only know the hash. We can go and paste the hash in and try to authenticate to SMB. And you can see right here, it says pwned, which basically means that we can run commands as administrator, just having the hash off of that. So if you can get NTDS and the system file off of Active Directory, you can go and dump all the hashes and then run anything as a user, essentially. Any questions on that? The commands are basically like, even like the commands itself, like for the first one where it basically dumped all those files, I don't even know what exactly it did there, but I know its purpose, which is that I grab those files, I copy it over to my machine, I run that program, and then it dumps the hashes, which is like the output that I want off of it. Any questions on that?
Are you going to have that also along with our resources for this week?
Yeah, so I'll make sure to post the recording of this like ASAP, but yeah. LSASS we can use with Mimikatz. I think I have that. Yeah. Okay, this is the LSASS one. So LSASS we can use Mimikatz. I mentioned Mimikatz is a way to go and extract passwords. So we can use So we're running Mimikatz on a compromised server right here. And basically what we can do is just run this, oops. If you see right here, I'm doing like a secure LSA login password. If we run that, you can see that there's like these NTLM hashes being spit out right here. And we can get access to those as well through the LSASS process, which is a process used to authenticate things. And then the last one is DPAPI. And we mentioned like that's the one with like Chrome secrets and stuff like that. So we can use Mimikatz with that too. So Mimikatz can go and dump the like, dpoppy. So you can dump cookies, which we mentioned is basically like sessions of whatever website you're on. But the important one is Chrome credentials. So basically you can go and access like your Chrome data, and you can see that for twitter.com, this person had this username and this is their password right here that's obfuscated out. So you can basically log into a Twitter account just because of that. Any questions on that? So use Mimikatz on a compromised server to go and do that, or a compromised computer. How? You need to get access to it. You use like the commands we were talking about before. So you need to find some way to execute code, remember? So the whole thing is like, you need to identify some sort of way in. So either they have something running that's like old and has exploits to it. Maybe they have like a web app vulnerability to it. So you use those and try to get a connection to it. We mentioned reverse shells early in the beginning, right? You need to establish a connection somehow to the server. Once you do that, then you can start doing these things to go and like dump credentials and stuff like that. That makes sense?
So the first step is to find a place to run code on. So
Yes, you need to find a way to exploit it.
create a shell.
Yep.
Basically whatever we want.
Yep. Yeah.
I mean, I guess I basically have the same question. So this is all like the next step in the process.
Yeah.
right?
Yeah, so it's assuming you already have some sort of access. And then me and Sophie this week are gonna like make like 2 or 3 videos, like walking through like, we're gonna be doing like a try hack me machine that we've never done. And like walking through our thought process of like, we nmap, we try to find out how it's vulnerable, we get a shell, and then we start doing things like this to find out what to
So the
do.
overall process is always the same.
Yeah, it's always the
Can I
same.
practice stuff like this?
Where?
Yeah.
Try hack me or hack the box.
Yeah, open hack the box. It only gives you like 2 hours per day.
Hack the box?
Yeah.
Yeah.
Oh, really?
No.
Yeah.
Wait, no.
Adam? No,
Unless you subscribe to it.
that's TryHackMe. TryHackMe has, but the thing is, if you connect with OpenVPN, you can do as much as you want. It's just the attack box where it's like there's a GUI within your browser that's like limited.
Yeah, that's something. Oh, so I can access it from somewhere else.
You can access it with OpenVPN, yeah. You know how we like,
You just sent it.
Oh, okay.
Yeah,
that's
Also, there's no
unlimited.
limit on it.
Yeah.
yeah. Yeah, and for your homework, it's gonna be like 2 or 3 try hack me's. And the nice thing is that I posted on there too walkthroughs with it. So someone made a YouTube video of them going through it from start to finish. And I'd suggest not doing the box on your own, but watch the video and follow along with it. And then if you have any questions like, why did he do this? Why did he do that? Ask on Discord, and then I'll help you like figure out why he did that exactly. But the videos I posted, they're actually pretty like, yeah. They'll say, oh, I'm doing this because of this, not just run this command. Okay, next thing. Yeah. Because like when I first started off, it was a lot of just like shadowing, just like following what people did and like trying to understand like, why did they do that? Why did they do this? Why did they do that in a certain situation? Yes. And then we already mentioned this, pass the hash. Basically, pass the hash is basically the idea of if you were to get an NTLM v1 hash, which we mentioned before, of a user, and then throwing that into login, that's all pass the hash means. So you're just grabbing the hash, passing in to the login and logging in as that. That's all it is. Okay. Windows exploits. So you guys were mentioning like, how do I get on, right? So there's 2 big ones. There's Eternal Blue and there's Zero Logon. And I have a video on this to make it a little bit easier. And after this was like 3 more slides and we're done. I know we're over time. Okay. Lots of videos open. Okay. Can people read that? Oh, is it too small? Can't read it.
I can sort of read it.
Okay. God. Okay. All right. I'll try my best to go basically describe what's happening. So basically, this whole thing right here. Does anyone know what this is? Just like looking at it, if you can even read it. This is Nmap, right? Yeah. Yeah. So this is Nmap. And basically, Eternal Blue is an exploit on SMB, so the file sharing. So on like Windows Server 2012 and under, it's actually vulnerable to SMB. I think the NSA actually made that exploit, and it was like really destructive. So basically, the whole point of Eternal Blue is it's an exploit against SMB v1, which is like the old version of SMB, because they have 2 versions, v1 and v2. The old version of SMB v1 if someone is running SMB v1 on a Windows server that's basically that's Windows Server 2012 and under, you can basically go from nothing to full compromise in one quick sweep, basically. So the way you do that is, so you run your Nmap scan, right? Because you need to go and identify information. How the hell do you even know that it's running Windows Server 2012, and how do you know it's running SMB? So Nmap will tell you that. So Nmap, it says 445 right here, which is SMB. Yeah, what's up?
So what like dash is used for that?
It's right here. It's -SCV and -P dash. -P dash is all ports, and SCV is basically you want to identify the versions and a name of the service that's running. That's what that does. And it runs like scripts to like do more like enumeration and like identify more things about it.
This is already on the Kali, right?
Yep. Yeah. All this is already on Kali. All this, like, I'm not using any like proprietary tools or anything. Everything I'm running on here is already on your Kali. So yeah, we see port 445 is open, and Nmap actually ran scripts to get more information out of SMB. And then what the interesting thing that I found is it discovered what operating system it's running, and it says Windows Server 2012 R2 standard evaluation. So that means Nmap identified that it thinks it's running Windows Server 2012. So knowing that, and it's running SMB, I mentioned before that if it's running Windows Server 2012 or under, it's probably vulnerable to Eternal Blue. So what we can do is use Metasploit. We mentioned Metasploit, how it has a bunch of exploits already in there. So knowing that, I run MSF console, like we mentioned before. It loads. I open it up, and I search on the bottom, Eternal Blue. And I find a bunch of these modules. I pick the first one right here, because I picked the first one right there, number 1, because it says remote code execution. So I want to run commands, right? So you can type in like use 1 to use that module. So I type in use 1. And now I'm using that module, MS17010 psexec, which will run commands. And the thing with Metasploit, and you have to do this in your homework too, is you have to specify some things for it to run. And it says required right here. If it says yes, it's required. If it says no, you don't need it. So the two things it needs is rhost, which is remote host. Basically, the thing you're attacking is the rhost. And then the last thing you need, actually, that's basically the only thing you need is an IP address. So you can type set, and then whatever it is. So I type set rhost to the IP address, because the IP we scanned before was 10.100.10.41. That's the thing that's running Windows Server 2012. So I set it, and I type in exploit. It does a bunch of stuff right here. And if I type shell and hit enter, I have a shell on the server, just like that. Just using Metasploit, typing in IP address and hitting exploit, I got access to something that easily. So you guys are mentioning like, how do I get initial access to something? If something's vulnerable like that, you use Metasploit, enter in the IP address, enter in the port, enter in whatever it's asking you to. You type in exploit, you get a shell that easily. So now you have access to something like that. So you can see, yeah, this right here is a shell. So now I have access. So this is me getting access to the server right here.
And the shell, type anything in there, you can
Run it on the server. Yep.
and modify it.
You can do whatever you want.
Okay.
And the thing where it says NT authority system, this is like root on Kali or on the Linux in general. So that's the highest permissions you can have on a server. So by you running this exploit, you went from absolutely nothing to full compromise in 1 minute.
What would you want to do instead when you're inside? So like, do you want to shut it down? Do you want to?
Well, for penetration testing, you would just say your SMB is vulnerable. So that's like one way in, but then you try to go and assess more things internally about it. That's wrong. Yeah.
What can you actually do?
Whatever you
Like
want.
something useful.
Useful?
Yeah.
Are you saying in like a malicious sense or
Yeah, like in a malicious sense.
What would a hacker do?
an actual hacker?
Yes.
So if they have full compromise over a server, they would ransom you, because remember that if you, for a server, you have delegation over everything, right? So if you were to like have that higher permissions in Fullerton College, you have access to IT, HR, every single student, basically anything connected to Active Directory, you have full access to. So imagine like it was also connected to like rooms, printers, stuff like that. You can basically say, I want $10 million, I'm deleting absolutely everything. You can imagine how detrimental that would be, because now the school is non-functional, that's money being burnt, and that's gone.
Can't you have a backup for it? Even if you delete that.
What if they have backups in Active Directory? That's why, like, if you take like security plus or something like that, like certifications, they talk about like you need some sort of way to like have a backup in case something like that happens. So having a backup on Active Directory is a terrible idea. You should store it somewhere else. Maybe not even on the internet. So yeah, that's what you can do. That's the most common thing. If people will get the highest permissions, it's called domain administrator. They'll get that and basically say, yeah, we're ransoming you. And when they say ransom, basically what they do is they'll encrypt every single file everywhere. So you can't open anything, everything's encrypted. They have full control over you. They'll say, we'll give you the password to decrypt everything if you give us $10 million. And they actually will, because you're probably thinking they won't actually do that. It's like a business to them, especially people in Russia, it's like a business. So you give them $10 million, they will give you the password and say, bye, thanks for your business. They'll also even troubleshoot with you if it doesn't work. It's absolutely insane. Yeah. Yeah, it's no joke. Yeah, so that's that was Eternal Blue. There's one more, which was there's Zero Logon, which is actually pretty new. This is Windows Server 2016. Basically, Zero Logon is a vulnerability in their net login protocol. So it's like their authentication protocol. Someone actually found a vulnerability in the authentication protocol to go and make it so that you can basically go from nothing to dumping all of the credentials of a Windows Server. So that's crazy. And I'll show you what that looks like too in a second. So, and also uses Metasploit too, because Metasploit is amazing. So, yep.
So all of these tools are already installed.
Yeah, everything I'm doing on these are already on Kali Linux. Yeah. So yeah. So that's why I mentioned like use Kali Linux because it has all the tools you already need for it on there. Okay. So I basically have like the same nmap scan again. But the main things I'm looking for in this one is I'm looking for Windows Server 2016 and under because Zero Logon works on that. So I find that it's running Windows Server 2012. And the three things I need is an old version of Windows Server, so 2016 and under. I need the net BIOS name, which is basically the name of the server, whoever named it. So in this case, it's called AD. And I need the FQDN, which is the fully qualified domain name. So that's the subdomain and domain, basically. And that's called ad.bricey.dev. That's what I called it. So with that information, I basically go on to Metasploit. I open it up, right? I search Zero Logon. There's only one module available. I type use. I use that one. And I type options. And there's three things I need, or two things. The NB name, which is the net BIOS name, basically the host name. That's basically what the server is called, whatever it's called. And nmap actually validated that for us. So if I tab back in, we can see the NB name, net BIOS name is AD. So we grab that. We set the name on the bottom right there. You see what says set NB name. I don't know if you can get it. I set the net BIOS name to AD, and all I need is an IP address. So I only need two things: the net BIOS name and IP address. That's all I needed. So I set the IP and the host name, and I type in exploit, or I type in options just to validate it again. Make sure I have everything required. So I have those two required right there. And then I hit exploit. It does some things and it says it successfully changed the machine account, basically the server to no password. So the actual server itself has no password now. And if you give the server itself, which is like the machine itself, no password, you can do whatever you want because it has extremely high privileges too. So what you can do is you can run that. You can go and dump all of the credentials on it with the machine account instead for the user. So we specified the machine account, and you can see we have hashes. Again, we love hashes. So we can grab like the administrator, whatever we want. So we're using crapmap exec again. We grab that, we grab the hash of it, copy it, paste it in there, hit enter, and pwned. So now we have code execution as the administrator, just off that. So if somebody has an old server, you can imagine schools have extremely old servers because they're like, that's too much work. Run that, full compromise. Yeah. Don't do that. Okay, yeah, so those are like basically two well-known exploits for Windows. But what about services, right? Because Windows also runs services. So we mentioned just like on Linux servers, you can have outdated services. So they might run things that's not native to Windows, but they run like their own like website. They run their own like file server, something that's not native to it. that might be outdated, that might have web vulnerabilities, that might have default credentials, so admin 123, whatever. So the approach is the same thing with that. You Google it, you run Nmap. Nmap will tell you the version of services that are running. Google it, see if it's vulnerable. If it is, run exploits. Metasploit probably has a module for it. Try default credentials, try weak credentials, admin, password, admin, stuff like that. If those don't work, try more complex stuff like web vulnerabilities. I'd probably do that last. Try those few things first. Like go for low hanging fruit. Try like keep it simple when you're trying to hack things. Don't try to go like too complex unless you have to be.
Like I learned all of this on Hack the Bugs.
And try hack me, yeah. Yeah, and then privilege escalation too. We mentioned that on Linux too. You can escalate your privileges to something higher. The main thing that you can go and escalate privileges on is like services are running internally. People might have passwords that are weak. There's scheduled tasks, startup items, so things that are running on boot. Maybe you can go and modify an executable so that if something runs on boot, you can change it to something else like a shell and it gives you admin privileges, something like that. So you can do all these things. And then the most common one in industry is AD misconfigurations. We mentioned Bloodhound, how just that one group getting access to it gave full compromise. So getting access to like misconfigurations and abusing those is really common. So yeah, that's like the main way you prevesc on Windows, and there's a lab for it for the homework. But yeah, that's it. There's obviously no lab because I had no time, but yeah, that's it. That's Windows. Also, like I know I said intro, but that's like fundamentally everything you'd probably need to know as like someone starting out pen testing. That's like a lot of information. So yeah.
So on try hacking, I think there's one module that I saw which is like Windows fundamentals.
Yeah.
Do you recommend that?
I personally don't because it's super boring. It's like teaching you like, oh, what's like, it's like really boring. Like it's teaching like administrative stuff. So it's like, what's the control panel? How do you like uninstall an application? It's like if you use Windows, you don't need to do it.
Oh, okay.
Yeah. I can open up the PDF actually and show you. So these are the ones you're doing, and note that like almost all of them have a walkthrough with it. So you can go and watch someone do all these rooms and follow along and then try to understand like what they're doing. And a lot of the topics that we talked about here are also on these rooms. So yeah. And then when you do like the tryouts, it's basically you just do the same approach. You'll notice that there's a methodology to pen testing. You scan something, you search Google for like known exploits, you run Metasploit, you get a shell, stuff like that. It's like rinse and repeat a lot of the times. So yeah, after doing these, and me and Sohi posting like a video on like other stuff too, you'll start to get the gist of like how you get from just initially scanning something to finding the exploit to getting a shell and then going from there. So yeah. Any questions on that? Also, I don't know if you guys heard, but next Tuesday we'll supposed to be on lateral movement, which is basically if you get access to one host, right? How do I go from one host to another host? That's what lateral movement is. I think it's kind of out of the scope for CPTC, the competition. So what I want to do on Tuesday is basically leave it to like an open session to like ask questions. I was going to teach one thing, it might take like 20 minutes, but after that, like an hour and 40 minutes of just whatever questions you have. If you want to like walk through a machine too and like show my approach, and so he can do it too, we can do that too. So whatever you guys need on next Tuesday. Yeah. Yes. Okay, I think that's it. So I'll stop the share. And yeah.
I can't